Hi and welcome to a new SimplyMaya tutorial. In this tutorial we're going to look at something a little different. We're going to look at 3D printing within Maya, and more specifically in this case technical 3D printing, which will require a very high degree of accuracy. Now this sort of modelling is a little different from the sort we do for the entertainment industry. It's a little less focused on surface topology and a little more focused on accuracy. Now while Maya itself is capable of this, of course, there are a ton of pitfalls to fall into and various different modelling techniques we'll be using. So throughout the course of this tutorial we'll be building this enclosure you can see here, in fact everything you can see on the screen, and we'll be discussing various ways to get accurate technical models out of Maya. I'll finish off by doing a print of the final model here, which I have prepared, just so we can all see that it goes together with that degree of fit and finish and accuracy that we're looking for. So this one should be quite a fun one and a little different from the norm. If you've any interest in sort of 3D printing, this might be one for you. So thank you very much for watching, and I hope to see you in the first part where we'll be discussing various scaling options for this kind of thing. Thanks for watching. Hi, welcome back. So this is actually an addendum to the main tutorial. If you want, you can skip right ahead into the next part. This is just hopefully to clarify some points that came up during our testing for this. Now, one of the things I want to talk about is scale, because while we mention it briefly in the first part, I think we could take a bit more of an in-depth look at the scaling within Maya and why we do it the way we do it. So by default, Maya will be set to a scale of centimeters. I believe that's what the default installation leaves it on. So you would expect if you came into here and did a 5 by 5 centimeter cube, so just scale this up 5 Maya units, which should be 5 centimeters, you would expect this to be 5 centimeters when you exported it. And when you're doing a 3D print that needs to be, extremely precise, you rely on this. What's going to happen, however, is Maya's going to export an order of magnitude smaller than you think it is. Now this happens quite a lot with Maya. It happens when you're exporting to things like Marvelous Designer as well. It's just one of those things you have to deal with. In fact, if I go ahead and export this guy now, so I'll just export selection, and I'll export this to a file called box 5 centimeters, and then open it up in a 3D print slicer, just so you can see what the scale will be. Okay, so here I am in a slicer. I'm going to get a file, open files, and I'm going to open that 5 centimeter box. Now these units on the floor here, this would be 1 centimeter, so you can see what I'm talking about. Instead of 5 centimeters, it's 5 millimeters. Now if we're working in metric, this is extremely easy problem to solve, because when I'm working in metric, and indeed throughout the course of this tutorial, I will be using millimeters. So 5 centimeters is 50 millimeters. We would just come up here and change this to 50 for 50 millimeters, even though Maya is in centimeters. Now when we export, we'll be exporting in the right size. So as I say, for metric, this is perfect. It means we can work in millimeters, get the accuracy we need, and as long as we're working in millimeters, we'll be on the right scale. So just something to bear in mind, this wouldn't actually be 50 by 50 centimeters on export, this would be 5. Now this is a little different when it comes to imperial measurements, so inches in this case. If I were to flip my viewport here over to inches, so preferences, settings, and then flip it to inches. Okay, if you're working in imperial, and if we do something that's approximately 5 centimeters, so 2 inches, just so we have a comparison when we export in a minute. So if I bring my box in and I'll go 2 by 2, so 2 by 2 by 2 inches, there we go, and you would expect this to be 2 centimeters. However, even when working in inches, Maya's going to export an order of magnitude smaller. So if I export this now, it will in fact be way too small. In fact, let's do it and just show you. So file, export, selection, because scale is very important in a thing like this. So box 2 inches, yes, and let's open this up in our slicer. So I need to come down here, find it, there we go, file, import, so open file, and I'm going to take the 2-inch one. Okay, and as you can see, 2 inches being approximately 5 centimeters, it's also come in at 5 millimeters. So, or 10 times smaller than 2 inches. Now, in metric, as I say, it's not an issue because you can just basically use millimeters instead. In inches, it can become an issue. If we wanted this to actually be 2 inches, we'd have to change this to 20 by 20 by 20. And then you'd have to model everything 10 times bigger. But this can be a pain when working in imperial units. So what I would recommend is for you to get all the things that you need. So let's say like this guy here. And group them together, so Control G, and then just make the entire group node an order of magnitude bigger. So 10 here. And that will scale everything correctly for when you want to print it. Now I'm going to recommend that you work in millimeters. It's an easier workflow when you're going between lots of different packages, but I know a lot of people are just far more comfortable in inches, and that's fine. You go ahead and use them if you want to. It's not really an issue. You just have to remember that it's going to be an order of magnitude smaller than you think it is, so you have to scale it up at the end. Now the other thing I wanted to stress is throughout the course of the tutorial you will see me not use the transform node here. So for instance, this is 1 inch, or in fact let's set this back to centimeters before I do anything, just because I'm personally more comfortable in it. I learned both metric and imperial at school, but I've used metric for quite some time now. So let's set it back to centimeters. There we go. And let's introduce a couple of things. So a couple of primitive objects. Now, according to the transform node, the scale on this is 1 by 1 by 1 centimeter, which it absolutely is. Okay, 1 by 1 by 1. But if I look at this one, this also says 1 by 1 by 1, and it clearly isn't. If I go under its input node, you'll see it's got a radius of 1. Which makes it 2 centimeters. It gives it a diameter of 2 centimeters, which if we push it along the grid here, it actually is. If we can line that up, you can see that's 2 grid units, 2 centimeters. So for various reasons throughout the course of this tutorial, I won't be using transform node here. I'll be using the input under this to size things. So instead of selecting my box and changing it up here, if I wanted a 5 centimeter by 5 centimeter by 5 centimeter box, I would change it down here. Now this has another advantage in that I can freeze the transforms on this. So if I go to modify freeze transforms, you'll see everything here is reset and everything here is not. So I can still come and click and find out what the original dimensions of something were. It's also a little more accurate to work under the inputs. As you can see in the case of a polycylinder, you get things like the diameter in there as opposed to just scaling nodes. So that's why. Now normally in Maya I wouldn't do this, because even if I was creating something for a simulation that required a specific size, normally if it's 181 centimeters or 185, it makes little difference. In something like this, where we need ridiculously accurate measurements, however, it makes quite a big difference. So if you see me using the input node for scaling, that's the reason why. It's just a little accurate. I can freeze the transforms. One thing to be aware of, however, if you delete the history on the object, you will lose this. So, there is a price to pay there. Now, the other thing I wanted to just quickly address is Boolean objects and why I use them on cylinders. So you'll see me do this a lot. If I have a 3mm hole to drill in something, I'll put the radius of this to 1.5, which makes it 3mm. I'll then duplicate this special, so edit, duplicate special, and I duplicate special to preserve the input connection. I can then come under here and say make it twice as large. I can then use the original cylinder as a drill bit, so to speak, to just drill a hole through this, which I'll show you in a second. So in this case I would want to make this a bit longer because it has to completely bisect the object it's drilling through. I'll just make that 5. And before I do a Boolean operation, I do think I make this clear in the main tutorial also, you want to keep a copy of this. So just edit, duplicate special, because as soon as you use it in a Boolean operation, it's going to disappear. So I'm going to take this. Order of selection is important in Booleans, which we also cover in much greater depth in the tutorial, but for right now, let's just put a hole in this. So now I've got a hole in this, and if you're thinking to yourself that could have been done with a poly pipe, you're absolutely right. If you go to create, let's see, polygon primitives, poly pipe, you could have done the same thing with the inputs here, with the radius and thickness, taking one away from the other. I find that can be a little more confusing. I never do this type of Boolean operation in normal Maya modeling, and the other reason for 3D printing, this is exactly the way I do it. For other modeling in Maya, I'd always use a pipe. And one of the reasons I do it is often when I make something like this, there'll be something behind it that also needs a hole in it. So let's just say this was the back of a case, an enclosure, a camera mount, whatever it is you're making, and this was to support the screw, and then another hole goes through the back. Well, I now have a copy of my Boolean object to just shove through here. And again, always take a copy of your Boolean objects. So edit, delete, duplicate special, and shove one out the way. We're going to select this and this, mesh, Boolean, difference. And you'll see I've now cut a hole in here which precisely matches this one. So I just wanted to mention that if you want to use a poly pipe for these sort of operations, please go ahead. Me personally, I like the Boolean technique when it comes to 3D printing for stuff like this. I believe it gives a little more flexibility, and you know, it's just one of the ways I've chosen to do it. If you want to use the pipe, please do. And again, the same goes for if you want to use inches, please do. Just be aware about the order of magnitude thing and grouping everything together. So if you're brand new to Maya, don't worry, we're going to go and explain these a bit more in the main tutorial. I just thought these ones would require a little more explanation, maybe for some people who are wondering why we did certain things. So I hope you found this somewhat interesting, and I'll see you in the first part. Thank you very much for watching. Hi and welcome back. So in the previous part, we got a good look at what it is we're going to be creating. Now, before we just jump right in and start modeling, I want to cover a few very basic points of Maya. Now, the first thing is my workspace here is set to Maya Classic, and depending on your workspace, your interface might look different than mine. Now, if you're comfortable in Maya, set the interface to look however you want. If you're just beginning, however, I would recommend that you set your workspace to Maya Classic. It will be easier to follow along with what it is that I'm doing. Now, the second thing is, especially on a project like this, but really any project for Maya, you need a project directory. It stops your files becoming just hopelessly lost. It stops, you know, every time you open your scene file, Maya not being able to find the assets. So we're going to come up here, we're going to go to File Project Window and hit New. We're going to give it a name and a location. You can change by hitting the folder here. And what happens is this will create a directory for you on your hard drive, depending on where you've put it. Now, within that directory, it will be a bunch of folders that Maya has created that will allow you to keep your scene files and all your reference work organized. So for instance, anything that goes into source images will be seen as a texture by Maya, so if you reopen the file you won't have to reapply all your images. Scenes is, you know, fairly self-evident. It's where your scene files will go, and the rest of this is for animation, simulation data and everything else, should you have any of that on your project. So now we've got the very basic. Just hit accept when you've got a name you like. I already have a project for this, so I'm just going to shut down the window. Now we come to rather than meat, nuts and bolts of this. With 3D printing, especially for a project that we've chosen, which is to create a enclosure for a specifically sized object. Now that object could be anything. In our case, it's a cheap LCR meter. It could be for a Raspberry Pi. It could be for building your own gaming handheld. It doesn't really matter. What we need to get is accuracy, which means we'll need an accurate reference image. We'll also need to do quite a few measurements. So an accurate reference image, though, will help immeasurably. So I'm going to dip into Lightroom here, and I've got a couple of images in the display. Now, one is just a reference image. This is a cheap multimeter I own, but I quite like the ergonomics of it. So when I design a case for my own, I'm going to have this sitting on a second monitor as a reference image, just to keep in mind these nice curved ergonomics. Now, I might prefer a bigger curve at the top or a steeper incline at the sides, but this is just to give me a view of what it is that I'm trying to create. So I'm not going to use it for measurements, because what's going to fit inside here and what fits inside mine is different. This is purely visual reference. Now, the circuit board itself, however, is definitely not a visual reference. It's not by which I mean it's not something I'm just looking at and then in Maya going, it seems about the right size. I need this image to be as accurate as possible. So I'm going to go into develop, and you're always going to get some lens distortion. I don't have access to the best camera equipment in the world, and I'm sure most of us don't, so we're going to have to put up with some lens distortion. It's just the way of things. Now, we can minimize that by coming into Lightroom here, and I'm going to crop this image down. We don't need all this unnecessary fluff. Now, you'll notice in my reference image is a ruler. This is just going to act as a handy guide. I'm going to double check everything with measurements, but with this ruler here, I can basically intersperse all of these black lines with grid lines in Maya and get the scale of this object, if not spot on, pretty close. The other thing is this is slightly twisted, and we definitely don't want that. So I'm going to come down. You can also take this time to change your exposure and anything else you might need to do. In my case, I'm not going to be on the cover of a photography magazine for this shot, so it's purely just for reference. So honestly, the highlights and whatnot are of no interest to me at this point in time. Now, I shot this with an 85mm lens, or 75mm maybe, somewhere around there. Now, I did this to cut down on the amount of lens distortion. If you'd have shot this thing with a fisheye lens, it would have been completely distorted, of course, and almost no use as a reference image. Now, depending on what you shot your reference with, you might need to enable a profile correction. For me, it's not going to make that much difference. I'm just going to select a 75 or 80mm lens here, 85mm, close enough, and you'll see that has a slight impact. If I was using a 35mm lens, the impact would have been much, much greater. So let's go to transform and straighten this up as well. So I'm going to go for a guided transformation, and what I'm going to do is left click on the edge of the circuit board here, as close as I can get it, and then hold and drag out to the other edge. So I'm creating a straight line here. Now, you might want to take some time over this and get it precise. I'm going to do this fairly quickly just to avoid boring the pants off everyone. Now, you'll need two lines for a guided transformation, so in this case we're going to do two on the horizontal, and I'm going to come down here and guide that up to the edge here as well. Now again, this can be a bit finicky, but you should see that now straightens up. But now it looks a bit like a parallelogram, so I'm going to come in and I'm going to do another guided transformation down the side here. And again, we'll need two lines across the vertical. Now, this one's not strictly necessary. Again, this all depends on how you shot your reference. As I mentioned previously, mine was certainly not done with any sort of fancy camera equipment. It was done with bog standard Sony DSLR, one of the cheap ones. So, a phone camera is going to take a bit more editing probably, but if you've got any sort of half-decent camera, your reference shouldn't take that long to sort out, especially if you use a long focal length. So this is good enough for me. I might crop it a bit more because I really don't need any more than necessary in Maya. In fact, it's just going to get in the way. So let's crop that. That seems good enough. Now I'm going to export this image into Maya and then re-import it. So I'm just going to go to export, and I'm going to put this in my scene file, which for me is network scenes LCR case images, and I'm just going to hit export. Now I could change the file name, which I'm not going to bother to do because I'm not dealing with a lot of reference. So let's just export that, go into Maya, and now we need to import it into here. So I'm going to click space to get to the foreview. I'm going to click space again to maximize the front view. I'm going to go to image, image plane, import image, and I'm just going to find that within my directory. Now, because we set up a project, I just need to click on the left here, and there is my image. Now, my grid here is set to centimeter, I believe. Let's just check that. So Windows, settings, preferences, and settings, and we're in centimeter. Now, this is not going to matter. Each one of these grid lines is now going to become 1 millimeter. It doesn't really matter what I set the scale units to in Maya. I'm going to use one of these grid units as 1 millimeter, and when I send this as an STL file to my 3D printer, the size will be spot on. So the first thing we can do, just to get a general eyeball on this, is to scale it up until our whoops, I hit space there by accident, until our individual lines go 1 grid unit each. So this is never going to be the kind of accuracy you're going to want. And when it goes off the camera, I can middle mouse drag to scale that, so I don't have to do it in tiny aspect down here. I can actually zoom in pretty well and scale this up until I think it's going to be about right. So now I need to move this image. So I'm going to come in here, I'm going to get it on this one, and I'm going to move it, and this section here is a little tedious. Now I've gone back to scale, and I'm going to scale this back to move, of course, and you can see what I'm trying to do here. I'm just trying to get an overall sense of scale by matching each one of these lines up to its corresponding grid reference, and I'm just using W to move here. So this seems to, whoops, and R to scale. So this seems about right. I've got each grid line is about 1 millimeter. Now you can see here that as we go further along they get slightly less accurate, and on the other side the same thing happens. Now that seems to indicate to me we need more scale. So as I said, this can be a bit tedious. Okay, something like this is good enough, because what we want to do is make sure our reference was good, and we can do this by measuring the exact distance from here to here on the actual model. So in my case, the actual distance from here to here, as measured with my caliper, is 72.5 millimeters. So let's check how well we scaled up our reference. So let's go to Create, Measure Tools, Distance Tools, and I'm going to actually lock this distance tool to the grid by hitting X, and I'm going to do it on the central grid line here. X and clicking. Now that leaves me one locator, which will make up one distance point. I'm going to come over here, I'm going to click X, so place this on the grid line. I'm going to hit W to move it, and you will see that move out. Now when I've got those exactly on the board there, you'll see we are at 74.65 and we want to be at 72. So I'm going to move this down to 72.5. 72.52 is more than accurate enough, and as you can see, just using the millimeter spacing from the ruler, we weren't that far off. We were 2 millimeters off, which is not too bad. So I'm going to scale this down now and move it into position. Now one of the things I'm having difficulty with here is actually seeing the grid lines. So I'm going to click on my reference image, I'm going to come up to the attribute editor, and I'm going to turn down the alpha gain. This should help me both see the points here and where I'm moving the image to. So there we go, that one's in, and this needs scaling down a little more. Now you do want to be accurate with this. I know it's tedious, but you do want to be accurate with this. So that point here is dead on the corner of our board, and this point here is dead on the corner of our board. Now apologies if that's a little tricky to see on recorded video, but if I open the outliner, our window outliner, the outliner will allow us to see all the things in the scene. I'm actually going to dock my outliner by bringing it over here and just holding it and dropping it, and I select both the locators. You can see that we're pretty much spot on. Now if we go up and have a look at our ruler, it is also now pretty much spot on. So our reference image is looking pretty good, you know, all things considered. So that's going to be the basis, our starting point. We're going to use this to line up the holes in the case required for the switching, for the blue thing here, which is called a zip socket, and of course, most important of all, the holes. Because there's no point building a lovely case and then screwing it all together to find it doesn't quite fit right, and the holes for your, you know, whatever you're screwing in there, whatever you need to fasten within the enclosure are out, because this is just going to look absolutely dreadful. So when we come back, we're going to look at, you know, speeding this up a bit. For a start, I understand this part was, you know, very simple and slowly explained. So hopefully you bore with me through it, and we're going to start picking up the pace in the next part, where we're actually going to model a representation of the circuit board, which will make our case design much easier. So thank you very much for watching, and I'll see you in the next part. Okay, welcome back. Let's get into setting up our final reference here. Now, I know I've spent some time on this, but you need it to be as accurate as possible. Now, one of the reasons I like to include a ruler, as I'm sure I mentioned, is if we know this is 72.5 millimeters from here to here, and our measuring tool pretty much confirms that, at least within 0.1 of a millimeter, which is where you want to be. If our ruler didn't match up, we could say there was some serious perspective distortion going on. So I like to have the ruler in the reference shot, even though we're going to use more accurate measurements, just to double check that I haven't done something weird in Lightroom or whatnot. Now, if our measurements are correct, according to my caliper, from here to here should be 60 millimeters. So let's just confirm that to make sure nothing is going on. So we want to go to Create, Measure, Distance tool, and I'm going to click in as accurately as I can. I'm going to click here, and I'm going to go all the way down at the bottom and click around here, and let's see what we got. 59.96. So I would say we're pretty spot on. Now obviously this bottom measure here isn't quite straight, so let's straighten it up. 59.95. Close enough for our intents and purposes. Now you want to be careful not to have your measure tools at a diagonal, of course, otherwise you're going to get completely wonky readings. The cosine error is going to come and bite you, and we don't want that. So let's just make sure this is as straight as possible. And to be honest, this is well within the bounds of tolerance for 3D printing, so it's good enough for me. Now the other thing we want to do is make sure that our piece here is central to the grid. That way when we create something in Maya, if we want to model only half of it, or if we at least want it to line up with the case, it's easier if our reference is in the center of the grid. Now this one's not mission critical, so I'm going to do this by eye, and then just see how accurate I am by taking half the distance of this 72.5 here. So that should be 36.75. That sounds about right. So let's measure from our center grid line to the edge of the circuit board and see if we're anywhere near 36.75. So create, measure tools, distance tool, and again I'm going to lock it. So we hit the central point here, and I'm locking it by holding X on the keyboard. I'm going to lock it again and come out here. This also makes sure I got a straight line. So 36.75, 36.76. Okay, so it appears that we need to go a bit further to the left here. W to move, and just move that up. Okay, so our thing should be pretty much half now. This gives us a nice starting point. Now if we want, we can get rid of all these measurements. We know they're accurate. I'd recommend that you do take some time over this. As I previously mentioned, you're going to end up with terrible problems if your reference is out, in fact if your measurements are out at all. So I'll turn the grid off up here, and you'll see my reference has appeared in my perspective view. Now this is generally not what you want, so if we select our reference here, we can set it to only looking through, say, the front camera. Now right now I'm going to leave this just because it makes a nice point of, again, reference in the background here, but I'll probably end up turning it off at some point. So let's start adding some stuff to this circuit board. So let's add the PCB, the printed circuit board itself, this yellow thing here in the background, and let's just come up and create a square. Now I have the measurements of this PCB, so what I don't want to do is hit R to scale and start trying to scale this thing to match the reference. Now while our reference is pretty accurate, the measurements with our calipers will be even more so. So what we want is to have Maya move this to a precise, or scale this to a precise size. Now we can do this by going to the channel box under the polycube input node here. We've actually got a width, depth and height. Now this is going to be in millimeters for us. If you're using feet and inches, you might have more of a hard time with it. I would generally recommend for something like this that's going to go to a 3D printer that you use millimeters. But you know, your mileage may vary, it's not a requisite. So width for us is 72.5, we know this from our measurements, and look at that. So we almost precisely managed to match the reference here. I would say something went wonky with one of my measurements, so I'm actually going to move this a little here, and there we go. Now I could have just done this without the measurements by just creating the box itself, but I like to double check everything for something like this, because with the time for 3D printing, you know, the time to get it right is at the beginning. Measure once, measure twice, cut once, as they say, or in this case, measure twice, print once. So select our cube again, to the channel box, to the input node, and we need to select the cube, to the input node, and we know that our cube is also 60 centimeters high, or 60 millimeters, sorry, 6 centimeters, and that should match up pretty much precisely. Now if I wanted to, I could turn on X-ray here, so shading X-ray, and see how that fit. Now it does fit, but our reference once again is slightly in the wrong position, so let's come into our front view. But what we're interested in is these edges line up, and they seem to line up fantastically. So let's turn on X-ray for this view and select our cube, and you can see the green edges of this are almost a perfect match for our circuit board, which is exactly what we want. Now we want everything we create to stay at a 0, 0 grid reference. This is why we're moving the reference image, not the things we create. So you know, when we create a case, for example, if we get a very tight fit, it's going to be on the grid at the place it should be if we mirror it across. Now there are ways and means around this, but generally it's easier to move the reference image than it is to move everything you create to a different place within Maya. So we are good. We need a thickness for our circuit board, and in this case that would be 1.2 millimeters, so a depth of 1.2 millimeters, and we are done. So I'm going to turn off the X-ray here, and we can see that that's a pretty close fit. Now we have to be more accurate here than we are within most things in Maya. It's just, you know, the nature of this kind of modeling. In Maya normally would be accurate for scale for lighting or for simulation, but if you're building, you know, a 100-meter high building that a wave is going to crash against, it really doesn't matter whether it's 115 meters or 98 meters. I mean, as long as you're in the ballpark within Maya, because it's an artistic tool, normally you're fine. In this case we need to be accurate. So I'm gonna also, while I'm here, model the rest of this, of course. So that's given us our 1.2. Now let's put it on the top view here to this back facing the central line of the grid here, and let's create the ZIF socket and the screen, more importantly, because the screen's going to be a big one. We're going to have to cut a hole in the case for it. So I'm going to come up here and I'm going to start pretty much everything from a box. So I've got my box here. Okay, so let's measure out our box, and this would be for our screen measurement. Now our screen is 58.3 by 36.8 and it's 5mm off the board, so let's just plug that in. 58.3 and it's 5mm in depth and it's 38.6 in width. 38.6. Okay, so if we go into the front view now, we should be able to line up the screen pretty much perfectly with the screen here. And we do. Now, if this looks too big to you, it's because this photo is not very detailed, but there's actually clamps here running around the screen. So if we wanted to shove the screen through the front of the display, which we may end up doing, we also have to account for these clamps. Now, let's come up and move our screen back so it touches our circuit board. And that gives us a pretty good representation. Now, when we're modeling things for 3D printing, especially if we're building an enclosure around something, we need to know the maximum thickness, because there's no point building your enclosure, trying to fit it together and finding out the stuff that you're putting in there is thicker than the actual, case itself, is wider than the case itself, because then the case won't close and you'll be in deep trouble. So while I'm here, just because this is difficult to see, I'm going to assign a favorite material to this and just a Lambert, and I'm just going to make this a nice green circuit boardy color. So like so, and I'm going to call it PCB. Okay, and I'm going to make the screen here probably a blackish color to represent the screen. So I won't use pure black, I'll just use a dark grey. Pure black tends to make details difficult to see. And we'll come up and screen. Okay, the other thing we need to do is keep a very organized workflow, which is one of the reasons you pretty much always want the outliner open. So this is the screen and this is the PCB. When you've got something complicated, you've got hundreds of parts, the last thing you want to do is have, cube, polycube 264 on the display in the outliner, because you will never be able to find anything. Now, let's come back and make the rest of this really quickly. So, we know from our reference image we need this ZIF socket on the front. This blue thing is called the ZIF socket. So, we're going to look at that, and I have, of course, already measured this. So, again, we're just pretty much using a collection of square boxes here, folks. It's not rocket science, but we can, as I mentioned, use Maya to get these accurately sized. So our ZIF socket is, let's see, 33 long. It is 14.6 wide. 14.6, excuse me, a microphone is in the way of my numpad right at the moment, and 11.4 deep. So accurate measurement is crucial. I'm going to just keep beating everyone to death with that point, but I've worked on too many of my own projects where I've gotten a bit sloppy, and you end up printing stuff over and over and over again. Okay, so let's throw that so it's lying on the PCB as the original would be, and now we know that our casing is going to have to be at least this wide, because if it wasn't, nothing would fit. So let's give this a name, ZIF, and that should do that. Now we need to recreate this button here. So this one gets slightly more complicated because it's got some roundness to it, but not terribly much so. So the base button itself, or the black part here, the base of the button, is 12 by 12 by 3.4. So we're going to go 12 by 12 by 3.4. Okay, and there we go. Done. So let's move this into position. Now, this is where the reason we have a really accurate reference, or as accurate as we can make it, is simple. Because I can't get in here, this little gap, and measure it with a digital caliper. But because I know my reference is good, I can simply use the reference to do it for me. Now that's never probably going to be quite as accurate as, let's say, let's put this flat on the circuit board, as say having a proper, measurement of it. However, it's not always possible to get that proper measurement, and when I say slightly more accurate, I mean within sort of 100 microns or so, or even 50 microns are really the sort of tolerances we're dealing with here. Because we know our reference is accurate, we're good. We can just whack it on there and we are good to go. We're also going to use a reference to cut the holes. So we've got the base of the button. We now need the circular part of the button. So I've measured this here, and the circular part of our button at its maximum width is 12.6. So I'm going to come in and I'm just going to create a cylinder, which I can focus on here, and now I need a radius at 12.6. So our radius will be half that at 6.3. 6.3, and that will give us the size of our button at its maximum thickness. We also need a height for this button, how high it protrudes over the board, and that, according to my measurements, is 8.2. So we need a height of 8.2, and that should do our button. So I'm going to hit E to rotate, J to lock that rotation, and I'm going to use this view once again to line up the location of our button. Okay, zoom in a little bit and get it spot on. Now, the location of this is not so mission critical, as I do not like the button that comes with this, so we may well design another one. This has just given us a good basis to work from for when we're designing the case, because even if I design another button, I will probably go ahead and use the same sort of sizing. So I'm going to pull this out here, and in order to make this a bit easier to see, I'm going to go to shading, wireframe on shaded. Wireframe on shaded, there we go. Now I can see the outline of this. This is a little easier to move into it. Okay, and as you can see, that matches quite nicely with the height of our ZIF socket. So we know the button doesn't protrude so much that we need to make the case wider than the actual ZIF socket. Another consideration to take into account is if there's anything on the back of your circuit board. Now there is something on the back of mine, it protrudes 5mm, so I'll also have to take that into account. But we've got the very basics now of our circuit board designed. This is really the only things that are going to trip us up. Now we need this lever, but we're going to take that at another point. For right now, these boxes represent a fairly accurate look at this circuit board and its relative heights, accurate enough for us to begin designing the casing. Alright, so I'll be back in the next part when we'll continue and we'll finally get started with the casing design. Thanks for watching. Hi, welcome back. So let's get on with designing the case for this thing. Now we have a model for reference. Now before we do this, there's one other thing. You can see here there's a couple of wires leading off this. This goes to a standard square 9-volt battery. So let's add that into the mix as well, because if the battery turns out to be thicker than everything we have here, then of course the case sizing will need to be adjusted. We'll also need to fit the battery in the case. So once again, a box, and once again we're not using the scale tool within Maya, we're more changing the input width, height and depth. So our battery, now I looked this one up online because not all 9-volt batteries are created equal. So we got 48.5 as a maximum width for the battery. We have 26.5 for the maximum height of it, so 26.5. And we have a depth of 17.5. Now this should fit pretty much any battery, any 9-volt battery from any manufacturer, and we're going to move this back to the start point of the grid here, to the main line of the grid. So we can see if the battery would indeed be thicker than everything else we have in the case, and indeed it would. So if we had designed the casing just based upon the circuit board, when we came to put it together, bad things would have happened. So Now we've got all our elements, let's start to design a case. Now what we also have to bear in mind, if you remember the Lightroom images, there's 3 of these plugs to go on the case, so while we don't have to put them in right now, we do have to bear in mind that there needs to be room down the bottom of the case, traditionally on a multimeter or something like this, to put these plugs so we can access the functionality of the device itself. So let's come in, and right now don't need this reference at all. So let's click it and let's confine it to the front view. So attribute editor, and instead of looking through all views, looking through one camera, that will still make sure it's here, but it is now gone from here. So now we have the inner workings, we can design the outer workings. So I'm going to start once again with a box, and this time I'm going to use the scale tool because I'm going to put the box by eye. Because we have this reference to work from, we can now create any size and shape of box we want or enclosure we want, as long as it takes into consideration the dimensions of all this stuff. Now before I do that, I do want a maximum width to this. Now the optimal width for my 3D printer is 0.28 millimeters if I'm going to print the case as strong as I possibly can. So let's say I wanted 7 layers. For rigidity I need 1.96 millimeters, or 2 millimeters should be close enough. Now when it comes to 3D printing, the thickness of a material is obviously extremely important to its rigidity, as would be what you're printing the material out of. Now I'm not going to go into all of that in any great detail. I'm just going to say through my own experiments with an FDM printer, with both PLA and PETG materials, about 2 millimeters is quite rigid enough for this sort of case. Now your mileage may vary, so you can make it as thick or as thin as you want. Maybe you want something that prints faster but just doesn't have the robustness. That's also quite fine. Now the only measurement that's critical on this is the thickness. So we're going to go into the channel box once again and give it a width of 2 mil. Well, actually let's make that a height of 2 mil. Depth, sorry, don't know where my head is at today, my apologies. 2 mil. So that's the thickness that we want to achieve. So when we scale this thing, we want to make sure that we don't do this, because then we'll have lost our thickness measurement. So we want to scale out just horizontally and vertically until we get something we like. Now I'm going to move this in front here, and I'm going to get that to a point where I like it. Now I don't want to create a case that's any thicker than it needs to be, but it's also going to have side walls and things, so we need to take that into consideration. So about this thick will be good. And now we need a height. So we need to fit all the gubbins in plus the plugs at the bottom. So I'm looking at that. Now another thing to bear into consideration is how we're going to screw this thing together. So it's going to screw the front of the case, or the back of the case in this instance, to the front of the case that we will create. So you've got to leave ample room for things like screws. Now let's push a bit further so we can see our circuit board. Our circuit board also will have screws here. So we don't want to cut it too tight. And also I think I would like, more room down here. Now it's a bit superfluous to requirements, but I'm just eyeballing this in. It's all pretty much subject to change as we go along at this point. Okay, so now we have what should fit all of this gubbins plus the 3 plugs at the bottom. Let's come in and make this a bit nicer. Now we could just, of course, mount this onto a flat piece of plastic, but where would be the fun in that? So the first thing I want to do is quickly look at my reference here. Now I've got this open on another monitor, but just to remind you all what we're going for a sort of flowing shape that fits nicely in the hand. Now we're going to smooth this model, so we don't need to create that with too much geometry. In fact, too much geometry would be a terrible idea. So I'm going to move this out. I'm going to hit Control 1 on the keyboard to isolate it, so it gives me just this in the view, and I'm going to add some geometry here so I can basically curve this thing. Now Modeling Toolkit, Multi-Cut, hold Control, I'm going to curve it around here, and I'm going to hold Shift so I can lock it to the middle position, and I'm going to curve the top and bottom. Now believe it or not, that should pretty much be all we need to do. Now, before I did that, actually, what I would like also is to get a taper going on at the bottom. So I'm going to go into vertex mode, hit Q, select these two vertex, punch R, and scale this in. That will give me a nice taper all the way down the device, so it's not the same thickness all the way through. Now we should hit Control 1 on the keyboard and just make sure that that taper isn't, oops, I'm still got the vertex selected here, excuse me. Just make sure that that taper is not going to do anything ridiculous like chop the battery compartment off, chop the edge of the circuit board off. It looks good. So Control 1 to isolate this again, and now we can put in our cut lines. So probably going to want it to taper in around somewhere around here, and holding shift, get it in the center. There we go. Is that actually in the center? Yes, it is. Now the other thing I want to make sure we don't end up with is sharp edges. There's no point designing something that looks great if you pick it up and cut your fingers off. This is just not going to impress anyone. So we're going to round off the corners first. Now this is where our modeling takes a deviation from standard Maya modeling. Because we don't have to worry about quadrid topology and n-gons aren't going to cause us any problem at all, we can do this a bit quicker than we normally would, and that quickness also allows for a little more accuracy. So I'm just selecting edges here, and I'm going to select this edge here and this one here. I'm going to hit the space bar to bring the channel box up, and I'm going to go to Edit Mesh, Bevel. Okay, first thing, I'm going to add some segments to this. 4 or 5 should be fine. And that's a little too rounded for me. So you can play with the fraction here, and how I'm doing this, I'm holding my mouse over it and hitting the middle mouse button and coming up. If you want to be more accurate, you can also just type in the box. But for me, a little curve like this, yeah, it looks pretty nice. Now, before we do that though, that's simple enough. I want to get the top and bottom curve in. Okay, so I'm just going to pull this up a little bit, and I'm going to do the same on the bottom. Little bit. I'm going to hit object mode, and we're going to smooth just to see a kind of overall shape. Now that's quite difficult to see without the bevel in, so let's go ahead and put the bevel in. So I'm going to hit G for the last tool used, which should be bevel. I'm going to add my 5 or 6 segments. It's really not that critical how many segments we have on this because we'll smooth it later. And I'm going to come out probably about 0.2. Now I'm going to hit 3, and you'll see that's just a nicer curve up here. Do not worry about this at the moment, we shall fix it in a minute. And now I want a bigger rounded edge on the bottom. I also want to pull these in a little bit. Okay, like so. And select these edges here. Edge 1 and edge 2. And G to go back to bevel. Now I want quite a big bevel on the bottom, so let's give us a few more segments, 8 maybe. And we're starting to get some look of some ergonomics in here, even more so when we smooth it. Now I would like let's go to vertex, I would like these to be more pronounced. There we go, something like this. You can also move this line up and down to change the ergonomics of your case, but for me just something like this is quite nice. Now you'll notice that our geometry here has gone absolutely bonkers. If we were modeling this for a traditional Maya role to be used in animation, or even for a TV or movie shot, a background or whatnot, this is not the way you do it. Now I want to make that clear. This is not traditional modeling in Maya, which is one of the reasons I wanted to do the tutorial, because traditionally to model things like complicated enclosures in Maya would take a very long time and also be counterproductive, simply because, you know, all of the things in Maya set up for good topology are in relation to simulation, animation, you know, rendering, lighting, and none of that is necessary when we 3D print. Now that doesn't mean we can just go hog wild and completely ignore the topology, because if we do that, Maya's tools will actually stop working and we'll be stuck. So this is the trade-off you use when you use Maya for more CAD type work. There are certain pitfalls you can fall into, like if you completely mess up the geometry, the tools will stop working, which they wouldn't in a more traditional CAD package. But anyway, so that seems about right. Let's hit Control 1 to bring everything back. Let's push this along, and you can see here now we've got a problem because it doesn't actually fit anymore. So we're going to need to come in here and select this edge, hit R, and we're going to need to make sure that that is spaced up here. Now what I think I'd also like to do is put a gubbins here and maybe add another one here. Now here's what I'm talking about. So let's do this. Right, I can no longer okay, I've isolated the view while I was in edge mode and it hasn't isolated the whole object. Okay, I wondered where my faces had disappeared. So let's try and add another edge loop around here. So I'm going to do the same thing. I'm going to hold Control and add another edge loop, and you'll see I can't. And it's because our topology is now messed up. By which I mean, if you see where these edges finish, they all finish on this face. This face no longer has 4 sides. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's a giant n-gon, which means that Maya's tools have stopped playing nice. So I'm going to hold Control here. I'm going to put one in, and then I'm just going to manually throw this around because the edge loop tool has stopped working, but that's fine in our case. And I'm going to throw one here. There we go. And you'll also notice I'm paying absolutely no attention to if this line is straight or not. That's because it's very easy to straighten it up in a moment. So let's just hit return here and see what's happened. Okay, so these are not lining up. That's not good at all, but easily fixed. So go into right mouse button, vertex, click your vertex, use your target weld and weld this vertex to this vertex, and we should have a continuous straight line running around. Okay, so even though Maya's tools are not on the ball right now, we can still work within the confines of it. So select all the vertex, so I click drag select around. Now you might want to do this in one of the views where you can actually see you haven't selected any extraneous vertex. Hit R and scale downwards. This will straighten the line up, as you can see. Done. Now we have 2 lines to play with for our ergonomic style shape. So if we hit smooth here, this is already a bit nicer, already a bit like this, a bit more, but maybe I want to flare out the whole bottom a little bit. There we go, kind of liking that shape. And this, again, I'm just drag selecting these vertex willy-nilly. Bit more rounded up there, bit straighter on the bottom. Let's go back to object mode, hit Control 1 and make sure everything fits in. Everything does not, but that is okay because we can scale uniformly this way and make sure it does. Now let's have a look, bring it a bit forward. In fact, I'm just going to isolate the circuit board itself and this. I'm going to shift click on both of those, hit Control 1, and that circuit board fits in, but barely fits in. So how do we go about this? Select this edge, drag it down, select this edge. Let's have the ergonomics have to go a bit more like this, unfortunately. And if we put another line here, we can actually bow this out to make this more pronounced, which I think I'll actually go to the trouble of doing. So let's unsmooth it. 1 on the keyboard, 3 on the keyboard to smooth it. I'm sure I mentioned that, but now I think about it, maybe I didn't, so my apologies. And again, we're just going to cut around here, because this surface is also a large n-gon. So really, if we'd have thought about this, we could have added these lines before we beveled, and that way they wouldn't have been n-gons, and we wouldn't have to do this, but it's not such a big deal, really. Goes and hit go, and whoops, that looks bad. Yep, you can see here we've got an extraneous vertex. So I'm going to go Q to select the vertex, and I'm going to delete it because I don't need it. So I must have tapped the multi-cut button twice in a row there. I'm going to straighten this line up because we want to be neat, and there we go. When you can't pull down anymore, the line will be straight, and let's go. So Control 1, there is our circuit board. Let's hit 3 to smooth, and we want to move this line down a bit. Just gives us a bit more room to mount our circuit board. Control 1, and I'm pleased with the shape too. In fact, more pleased than I was. Okay, so one thing you'll notice, if we smooth this, it's no longer going to 3D print. It's just not going to happen for us. You know, it's now almost zero thickness, especially around the edges. So we're going to need to sort that out. We're also going to need to have some depth to this thing. I mean, it's no point just stacking everything on this and, you know, calling it a day. We need to create some depth. So we'll need to create the outer walls here, and then we'll need to create front of the case that precisely matches this one, because even if we're a couple of mil out, our case halves won't fit together. Alright, so I hope this has been somewhat interesting to you on our journey here to get an accurate 3D printed thing out of Maya, and I will see you in the next part. Thank you so much for watching. Okay, welcome back folks. So let's sort out this casing a bit more, this enclosure. Now you don't want this, the lines are too straight and sharp and this is all pointy, but if we smooth it with 3, you don't want this either, unless you're trying to create some sort of serrated bread knife. So let's sort that out. We also need to give this some thickness, some depth, so it fits all the components in, and you know, many things yet to sort out. So let's click here and come along, and what we'll need to do is put an edge that precisely matches this edge, so we can extrude it outwards to make the depth to the case. Now there's a couple of ways we could do this. We could, again, as we've seen, use the multi-cut tool and try to precisely cut an edge up here, but as you can see, that would be boring and, more importantly, completely inaccurate. So we're going to use the bevel tool. So we're going to select all of the faces on here, make sure I've gone into face mode, just right mouse button of course, and hold Control to select these faces. I'm then going to select the edges that these faces represent, so I'm going to hit Control and I'm going to go 2 edges and then 2 edges again, and you'll see I've selected all the edges around there. I'm going to untick all of these inner edges because we don't really want to be beveling those, we just want the outer edges. Then I'm going to go hotbox spacebar, edit mesh and bevel, and you'll see that's put a beveled edge on, but it's also put a chamfer on there which we don't want, so middle mouse drag that to off. And I also want 2 edges, so I want to extract this twice, to extrude this twice so the case locks together. So instead of segments being 1, I'm going to go up to segments being 3. I'm then going to get rid of both of these 2 edges. Now there is a method in my madness. If I bring back the bevel tool, that's not going to do it. We're going to need to go to the channel box. We're going to need to select object mode. We're going to need the bevel input, and then I should be able to bring back the bevel tool. Okay, watch this. As the fraction increases, oops, that's not the fraction, is it? As the fraction increases, you'll see these edges go backwards. Now these edges can only go back to a maximum distance of this, which in our case we know happens to be 2 millimeters. But the problem is, you'll see now I've got a double edge along here, which is really not what I want. And you know, it's easier for me to come in here and just get rid of it right away. Now you can, if you want to, get rid of it after, but I want to get rid of it first. So I'm going to come in, select Ed mode, double click on here, double click on here. Now you don't want to hit the delete key at this point if you're unfamiliar. If I hit the delete key at this point, it will leave vertex behind here. I'm going to do it to show you, and then I'm going to have vertex. You see I've got a bunch of vertex that I really don't want, that are going to complicate everything. So let's not do that. Double click, shift double click, and then holding shift, right mouse button, delete edge. There we go. Now I'm going to get my bevel tool back by going to poly bevel and last tool used, there we go, and I'm going to increase the fraction to 1. Now because we know it can't increase the maximum fraction more than this, we know each one of these are equidistantly placed, so they should be 1 millimeter each. Should be. Let's have some confirmation, shall we? So each one of these should be 1mm, and that, I don't know about you, but that looks like 1mm to me. So that's perfect. Now we've got accurate sizing on our case thickness. Okay, so I'm going to extrude these out to provide a case thickness, and rather than explaining it to you, I'll just show you. It will make more sense. So I'm going to select this, and I'm going to hotbox it. I'm just going to go to Edit Mesh, Extrude, Control E will also do it, and then let's say I wanted a thickness of 10mm. Again, we're about the accuracy, and then I want these cases to interlock, so I'm select this one and this one, hit last tool used, so G, and a thickness of 2mm to create the locking plate. Okay, now I need to do the reverse on the other side, so I have this one indented and this one extruded. But there you go, that's basically how we'd create some case thickness. But because I need its opposite number, I need a front of this case. I'm going to go back long before I did any of that, making sure that I don't have a dual extrusion, which I can do by clicking here and making sure this no extrusion appears. If you get a dual extrusion, I've seen it happen to a lot of people, so I'll demonstrate it. You come in here and you click Control E for extrude or use a hotbox, and then you decide you don't want it. So you just click away and you can't see anything, you think it's absolutely fine. What you'll find is you'll often get sort of micro faces, sort of faces that share the same point in space, and that would be non-manifold geometry, and that would be very bad. Okay, so we'll make sure we got no extrusion. We don't, but again, you can double check by deleting a face. If there's another face immediately underneath it, you've got some catastrophe waiting to bite you later on down the line. Now I'm going to come in, and before I extrude any of this MacGuffins, I'm going to hit Control D to duplicate. I'm going to move that out and make sure its pivot is centered. It is. I'm going to hit E, and I'm going to hold J to lock the rotation to 15-degree increments, and I'm going to spin it round 180. So now I can extrude these this way and these this way and perfectly fit the case together. Let's do a bit of housekeeping. Case front. And I'm just doing this housekeeping because it's something you should also do, but more importantly in this case, this has to be the battery, so you guys don't have to spend 4 hours watching me search for polybox number 26. I'm going to hit Control H to hide that, and now I'm going to work on this. So let's actually extrude this out now to a, let's see, select the faces. So click one, double click next to it, Control E for extrusion. Let's actually extrude it out to 10mm. Let's come in here, and which one do we want? This one, Control E. Let's extrude this out to 2mm to act as case lock. And there we go. Now, one thing we can do to make sure we've got no non-manifold geometry, because the geometry on this from a Maya point of view, what I've got here is an n-gon. As I explained before, this polygon, this one here, now has more than 4 sides. This is generally frowned upon with Maya, because if I wanted to bend or flex or run a simulation across this thing, it could cause potential problems. In the realm of 3D printing, it's no problem at all. But we do want to not have non-manifold geometry. And non-manifold geometry is geometry that simply couldn't exist in the real world. Now, if we give our printer something that simply couldn't exist, it's going to throw a major conniption. It's not going to be able to do it because there's no way to do it because it couldn't exist. So a good way to look for this, it's not always ultra reliable, but if I smooth this and I see no warning down here, I've probably got no non-manifold geometry. So I'm going to come up and I'm going to look at what happens when I smooth the side of this. Now this is completely useless. Look, absolutely useless. Those will no longer fit together in nice straight lines, so we need to fix that. Also, the back of this thing, when smoothed, is... actually, it's not bad. We could move this edge here to create more of a bevel at the back, but I really don't like that way of doing it, because what's going to happen is it's going to change the thickness of this thing here. So we want this to always be 2mm thick. So let's come in and do something about that. We don't want this razor sharp edge on the back here. It's not going to do us any favors at all. And this edge is pertaining... in fact, is this edge necessary? Let's do a vertex face. You know what, I don't think the outer edge is necessary at all, so let's get rid of it. Object mode, because what's going to happen when we bevel, this is going to be the limit of our bevel. Let's just select the edge and use a slide on edge. So you want to shift and right click and slide on edge. Where are you? Slide edge tool. And I'm just going to slide this out here. That's probably not necessary at all, but for right now I'm just going to shove it out of the way. Now I'm going to select the faces on the back and convert to an edge selection, so control right click, two edges, unselect the middle ones, and I'm going to show you why this is not going to work. Oh, it's going to look like it's worked, but actually I'll show you why this would be a bad idea. So we want to round over the back here, so we're going to go hotbox, spacebar, edit mesh, bevel, and you know, that looks like it's rounded it over. Let's get the segments here. That looks like it's rounded it over, no problem. But what's actually happened is if we do too big a fraction, you can see here that the back of the case is actually breaking through. So this part of the case is breaking through the back. So what that means is we've changed the inherent thickness of the case all the way through, which for 3D modeling purposes, for TV, film or whatever, is generally not a problem. For 3D printing it can be a big problem. And I think this will probably create also non-manifold geometry, which indeed it does. Okay, so this is very, very bad for us. This is not going to work at all. So let's bring back our bevel tool, and even if we're not bisecting the back of that, I think it would still create for us some non-manifold geometry. Now this is the thing we're going to have to deal with when we're modeling in this way, so let's get rid of that bevel. There we are. And how I'm going to do this, I'm going to bevel the front and back at the same time. This is probably still going to create for us some geometry we don't need, but we're going to deal with that as it comes up. It's just one of the things. Maya isn't a CAD package. While we're using it like one, still some pitfalls to be aware of. So let's select that, let's convert it to an edge selection. There we go. Let's select the edges we definitely don't want beveled. You can do this with just a face selection too. It should do the same thing. This edge selection method is probably not necessary. It's the one I've used for a long time, however, and it normally does the job for me. So let's come into edit mesh and bevel, and the inside and outside of the case should be beveled at the same time, which is good for us. Let's create some more segments here. I should create them on the inside too. And let's perhaps get a bigger fraction. Now you can see we can do a bigger fraction now, because as we do this, the inside also changes. So we should keep that uniform thickness. I don't want quite that much of a fraction, however, because I am going to be 3D printing this thing. So if I get too big a rounded edge, of course, then I'm going to be 3D printing with supports, and I don't want to print this with supports, so I'm going to keep that to a minimum. Now let's have a look. We're going to have some non-manifold geometry. Indeed we do. So easy way is to first do a geometry cleanup. Make sure there is nothing that's gone wrong. There is nothing, and you want to make sure also that your geometry cleanup includes non-manifold geometry. Okay, nothing to clean up. The result was nothing, so nothing will have changed. Alright, so we may need to do some manual jiggery pokery here. Now my first guess would be the easiest thing would be to remove these faces. These are probably what are causing the problem. So let's get rid of that, and let's get rid of this, and that is it. Possibly what's causing the problem. Let's have a look. Let's hit 3. Now we're absolutely fine. So easy enough to get those back, by the way. We're going to select the edge, and you should now be able to see, this is another good point, that we've kept a uniform 2mm thickness all around, which is nice for us. I like it. So let's come in here and select this edge, select the whole edge, and we're just going to go to mesh fill hole. There it is. This is a command that I really don't use a lot. And 3, you can see we're down. We've got no non-manifold geometry, no big warning down here. We are golden. Now mesh fill hole. Let's say I really never use this thing, almost. There we go. Object mode. Let's smooth, and we are good. So that gives us a nice beveled edge back here, but we've still got this problem that the case is not going to fit together because this is not nice and smooth. This one's a simple one to fix. What you need to do to hold edges together during smooth would be to multi-cut this side, and if I smooth now, you'll see that edge is a lot sharper. The difficulty with that is it's fairly inaccurate. It doesn't really matter in this case, we just hold an edge, but there's a better way to do it. Click all around anywhere where you want the edge to remain sharp. Let's make sure nothing on the other side, and then just bevel it. Mesh, bevel. You want to make sure the chamfer is off because we don't want it chamfered. Off. And you want one either side, so we've got one either side at good distances. You also want that fraction to be 0.1. You want it as tight as possible, because that way when we smooth, you can see these edges remain rock solid. Easier to see if I put it into object mode. There you go, we've got nice clean smooth edges. Now the whole model itself actually looks pretty good. The problem with it is, I say, is when we look at the geometry, you'll see this huge n-gon. Now, if we were modeling seriously in Maya, we'd need to connect these edges up and make sure this was all split into 4 polygons. In fact, this would be a pain, and it's not really necessary. But let's go ahead and just show you what I mean. So I'm going to cut across to here, I'm going to hit return, I'm going to cut across to here and hit return. I am going to cut across to here and hit return, and each one of these would need to be done individually. Now this I would most certainly do if I was working on this for a feature project or something. In fact, that one was a little wonky, because it would be necessary. If I was going to texture this thing, if I was going to use any of Maya's more advanced tools, if I was going to present this to somebody else to work on, then certainly would not give them a model with a screaming great n-gon in the middle of it. And I'll just show you how to quickly retopologize this so it works. But for 3D printing purposes, you can get away with not doing this. In fact, in a while we're going to be using booleans to cut holes in this and whatnot. So really for 3D printing, the retopo is completely unnecessary, but I'll just run through this right quick so you can see what the workload would be to get this into, you know, quaded geometry. And then we have a different number of edges up here than we do down here, so we'd have to do some edge tying and all that business. But that would actually make it possible, even in this instance, to, you know, properly quad up this model so it was ready for animation, simulation, or what have you. In this case it's not necessary, but it's something to bear in mind. And to be honest, if I was doing this for a film shoot, a production shot, or a simulated data, I was making something for the guys to simulate, I would have approached it a slightly different way. But just so you know, if you wanted to quad this out, all you basically got to do is line all your edges up, cut in between, and make the relevant changes to tie edges together. In fact, I've got a tutorial on modeling a Lego car which deals with some of the intricacies of getting fairly complicated pieces and shapes into one model with quadded topology, if you want to watch that. Anyway, we've got the back of our case done, so now it just remains seen. If we smooth it, do we have any? No, we don't. Okay, so I'm going to leave this one here. There's the back of our case done. When we come back, we'll quickly do the front of our case. It should take a couple of seconds, and we'll start slotting the stuff in, making sure everything fits, and cutting the holes in the front of the case for the screen, the LCD here, the zip socket, the switch. We'll need to design a battery holder. You don't want that running up and down in there, and we'll need to cut the holes in the front for the front plugs. But I hope you found this somewhat interesting. I hope we've covered at least a few of the pitfalls, like with our bevel leading to non-manifold geometry. You know, and I hope this has been of some use to you. Thank you so much for watching. Hi, welcome back. So in the previous part we did the back of our case here. Now I just want to take a look at the front of the case before we start cutting holes and shoving things in this. But what we've got so far is something that's fairly accurate and also something that has a uniform thickness and whatnot, which is quite important to our 3D printing process. So let's bring the front of the case back, which I'm going to do by Shift H to unhide it, and you'll see we have these lines here for the extrusion. So let's go ahead and extrude that out. Now at the moment we don't actually know how thick our case is going to need to be, so I'm just going to bring it out to a distance of 10 mil once again. So go into face mode, same as we did last time, click and then double click and then double click, and extrude this out. So Control E, or of course you can find it in the hotbox, thickness of 10 millimeters, and we need to pull out the top one. So let's come here, and this one, Control E, thickness of 2 millimeters, and we should find that our case halves here now perfectly fit together. So let's just have a bit of confirmation on that, and I'm going to turn on wireframe unshaded so this is slightly easier to see. There we go, and you can see that our case now locks together very nicely. There we go. Whoops, I hit the wrong button there, excuse me folks. But we've got a locking case that fits together. Now we'll need to add some screw holes to this, and also the front of the case. Again, we have that issue where we need to put a bevel in the back, so I'm going to use once again the slide on edge tool. In fact, this can just be deleted. And remember, when you delete an edge, you pretty much always want to go into Shift and right click and delete edge, or you'll end up with that vertex problem. Now I'm going to do the same thing. I'm going to select all the faces on the back, exactly the same procedure we used for, in fact before I do that, let's isolate this, so Control 1, so we're not fighting with the viewport all the time. We're going to use the same procedure we did on the back of the case, because we want to keep that consistency of thickness, very important for 3D printing. Now I can come up here with the control button and go to edges, honestly you can do this with just selecting the faces, but every once in a while Maya will give you some issues with that, and as we have a very limited number of internal edges here to deselect, I'm just going to take no chances. Now we very much will have to delete these faces in the end anyway, but right now we need them for our bevel operation. So edit mesh, bevel, and we can decide on the sort of fraction of bevel that we want. So let's see, what do we want? We don't want to go too thick, otherwise again we'll end up with having to do some case supports here, and that's really stopped whack in there. So let's see, let's go for about 0.6, slightly bigger bevel on the front, and make sure we've got that internally. Now I'm pretty sure when we smooth this we're going to get an error, same as we did last time. Easy enough to fix, same procedure. Get rid of these faces and then just use the fill hole tool. So select our edge here, a little bit difficult to see. Want to be in edge mode, and you should really use the hotkeys to switch between the modes. I actually can't at the moment because it interferes with my recording software, so apologies for the slight delays. And yeah, let's just hit G to repeat the last command, and there we go. We should now, if we've done our job correctly, find that this smooths just fine with no error down here. Okay, which of course it does. Now this bevel, to me, maybe I want it a bit more in depth, a bit more depth to it if you like. So this may or may not work because we changed the geometry, but it should be able to come down here, bevel, and put the fraction to say 0.8, and yeah, that still works. Let's do a 3. Yep, no problem at all. So just a slightly bigger bevel. Now hopefully that won't be a big enough bevel for us to have to print this with supports, but I rather think not. Now the other issue we're going to have once again is the edges here. If I smooth, you'll see this becomes like a dog's breakfast, no good to anyone. So edge, again, very simple procedure. And what we're looking for here is accuracy. So using the bevel tool to put the supporting edges in will allow us to make the supporting edge is the exact same distance as we made the previous ones, which was 0.1 on the bevel. So just go up to Mesh Bevel, and we can turn the chamfer off, very important, and set the bevel fraction to 0.1, and that should be identical to the other bevel. Okay, let's smooth this case. Hit Control 1 on the viewport here. Let's smooth this one and double check that they fit together. And they seem to fit together absolutely perfectly. There we go. So we now have a basic front and back to our enclosure, to our casing, and everything fits in. So what we need now is to design some of the extraneous bits. Now I'm just going to put this fella away, Control H, to get rid of him so he's not constantly in our viewport. And there's a couple of things we need to do. We need to design a battery holder, so our battery's not flapping about in the breeze, smashing into all our components and rattling and making us look, you know, rather amateurish in our design efforts whenever we pick our device up and it rattles and makes a large noise. We also need to cut holes in the circuit board to allow us to produce the location for the uprights here, because the circuit board's never perfectly flat on the back, and we're probably going to need to give this some distance to get it to where we need it to be. But first off, let's just design a battery holder. Now we've got the maximum size of our battery, and in this case it's really simple to cut a slot that it fits into. If we just duplicate our battery here, pull it forward and remove the two faces, so I'm just going to do this. This will give us something that wouldn't print, of course, because it's got no thickness. But if I double click, which will select all the faces if you're in face selection mode, and then extrude, so either through the hotbox or just Control E will do it. And then I'm just going to give this a thickness of 2 millimeters, because, you know, we want the accuracy. We want to be able to, you know, rather than just scaling this out and not being unsure of what's going on, we want to be able to get it as accurate as possible. Now, as you can see, that would perfectly contain the battery. The problem with this is that a 9-volt battery has some terminals on the end, and if we completely enclose it, we're not going to be able to plug it in. So thinking about it, that's probably going to need addressing. So once again, let's Control Duplicate, same procedure, front face, back face, get rid of them, and this time get rid of this space, so we don't have anything here. We're going to click, we're going to hit Control E to extrude, and once again a thickness of 2 millimeters. So this now allows us to have, whoops, that's not a good idea folks, there we go. This now allows us to have a battery holder that's open at one end. The thing is, the battery can now slide backwards and forwards, which again is going to make us look not very good. So I want to put a lip in here to stop the battery going backwards and forwards, but I don't want to make it so big that it interferes with the battery terminals. So we could extrude a portion of this out now and make it all one thing, but as we're 3D printing this, there really isn't any point. So if I just make something clear here, if I'm 3D printing something, unlike Maya where you'd normally try and merge the mesh together properly, if I just whack this in here so it bisects other geometry, a 3D printer will see this as all one object. It will not care if you've grouped it, merged it, joined the vertex together. If one object is intersected with another, it will just count it as one object. So if I want to do our basic battery holder like this, when this comes to 3D print, when Slicer gets hold of it, it will just see this whole thing and this whole thing as one object. Meaning that if I want to put a little bar in here, if I bring the battery back, so Shift H, if I want to put a little bar on here to make sure the battery doesn't slide around, all I really need to do is take a box, make sure that it is 2 millimeters. Let's pull that box out where we can see it. So make sure that it's 2 millimeters thick, and I've done that on the wrong one, not a problem, just E and J to lock the rotation. Actually, what am I doing? Yep, and then scale it. Okay, and actually I want to make this, okay, yeah, I need to make it 2 millimeters by 2 millimeters. There we go. There, right, okay, should have made them all 2 millimeters to start with, and then I can just scale it up. Sorry, having a bit of a senior moment. And I can now use this, maybe I want it a little bit higher than 2 millimeters, and just whack it in place as a battery stop. Now this will still be accurate for our 3D printing process, but we don't have all the trouble of having to muck around and get the perfect geometry. Now this bar is big enough to lock the battery in place, but it's also small enough that our battery terminals should be easily accessible. Okay, so that basically is a basic battery holder. Now we could design some clips to go over the top, but that would require printing with support. Obviously when I print my case, I will print it so this is the flat side, and if I have things jutting out this way, we'd need a support from the bed. Now that's not the end of the world, but I'd rather avoid that at this moment. What I'm hoping is the battery will be close to the limit of the maximum thickness that we need, so the front of the case will actually help secure the battery in place. Now I've seen it in many other designs where a bit of foam is put on the other side, because 9-volt batteries are slightly different sizes. So let's call our battery holder pretty much done for now, and when we do the final fit we'll see if the front of the case can be used to help it. If not, we'll design some clips. Okay, second thing, we now need to space this to a point where we get the components, the switch, the ZIF socket and the screen, in a position where we can cut holes for the front of the case. Now we know that our case, if I just move this battery back to where it should be, our case can't be any thinner than the battery, otherwise it wouldn't fit. So let's grab all these fellas which make up our circuit board here and hit Control G, call this main board, so they're all one group, and then we can start moving this around and seeing where it would need to be in order to clear the case. Now we could put it here, which would allow the case to actually, which would allow the screen to actually stick through the case, which might be nice. But in this particular design of this circuit board, being a cheap Chinese one, you'll see the ribbon cable here. It might not be clear, but it's actually attached to the front of the screen. So if I attempt to attach this so the screen actually sticks proud of the case or out of the case, I'm going to have issues here. And this is the sort of thing you need to bear in mind, of course, when you're designing something, whether it be in CAD or Maya for 3D printing. Things have got to fit. So I think what I'd like to do is make it so the bottom of the switch is not proud of the front of the case. I think that will be my limit. So if I come in here and I just move this so the bottom of the switch lines up with where the battery would be, and then if I can, I'm going to fit the front of the case in. Let's bring the front of the case in. So the case moves back, and the button, the ZIF socket and the screen, so the button will be proud of the case, the ZIF socket will be proud, and the screen will be just on the border of not sticking through. We'll still have to cut a hole for it. That should also allow us to use the case to help secure the battery. So let's bring the front of the case back, Control 1. Not Control 1, sorry, that would isolate it, Shift H. And let's move this to a point where that becomes a reality. So as you can see, already when we move in, the ZIF socket is proud and the button here is proud, but that's not quite as far as we want to go. So a couple of ways we can do this. We can actually decide if we want the case to be a clamshell with two halves the same, or if we want one of these to be recessed. Now I think personally I don't require this case to be split exactly in the middle, so I'm going to actually reduce the dimension of this. So if I hit Control 1 and Control 1 in this view, I can actually come in, select the vertex here, grab all these and move them back. Okay, now let's see how everything fits together. Oops. Making sure we have our vertex selected. So how I'm going to do this is I'm going to line these up in this view. There we go. And do we see the bottom of the button? No, we don't. So let's make this a little shorter. Vertex. We should be fine as long as we don't interfere with the bevel. As soon as we start interfering with the bevel, we're going to have to go and make the other side of the case smaller. Whoops, select the right one, of course. So how would we like it? We'd like it about here. So the screen is okay, and that bears in mind that our battery should be there as well. So we can't actually have it thinner than that. Okay, so let's pull this. Okay, that's perhaps still a little thicker than I'd like. But counting for tolerance in 3D printing, that should be about okay. Where is the battery? If we move back, yeah, remember we've got 2mm of thickness on the other side too. So I think that should be about right. I think I'm just going to make it a little smaller. And you should do this in the 4 view, otherwise you'll end up with vertex selected all over the place. And you really don't want a wonky vertex. Right, okay. Now the thinner I can make this as well, the nicer it is for me, because the less time it will take to print, of course. Okay, if I slam that closed, yeah, that should be about perfect. Now what we want to make sure, of course, if we hide this one, is that our battery compartment here is not actually hitting, or our battery is not actually hitting the front of the case, and it does not appear to be. That's not much, so we seem to have a good distance. So let's bring back the case back, Control H, and there we go. Now that leaves us with a case that's pretty thin. Like I said, I don't really want to print anything that I don't need to. Our screen is just ever so slightly sticking proud, which is not a good thing, but it's also not a problem because we can select the mainboard group that we did and move it back. We want to hide this again, and we want to move that back until the screen is not intersecting with the case. So where is our mainboard? Here. And there we go. So now we know the location of our mainboard. We can start to create some supports for it. So as you can see, our mainboard ended up standing quite proud of the back of the case. So we're going to need some supports. We're going to need to make those supports exactly where these holes are, because nobody wants a wonky display. It's just going to look horrendous. We're also going to need to put some supports in the back of the case here so we can actually screw the case together. And in this case, we really don't need anything fancy for our battery holder, because the front of the case is actually going to snug that up and hold the battery securely in place. Now from an engineering perspective, you might want to stick some foam on there on the other side of the case, so if you get a battery that's a little undersized, it doesn't rattle, because you know there's nothing like that quality feeling when you pick something up and it starts rattling on you. But other than that, we now have the front of the case, the back of the case, you know, nicely in a way where when we close it up together, the ZIF socket will stick through, the switch will stick through, and the screen should be, you know, right there when we cut the hole. We'll also create a small screen bezel, because again, it just looks very poor when you have a screen that's just sort of recessed back, and you know, it doesn't look nice. So we'll do some work on that. Also, if you look here, you'll see that our LCD, actually this part is not screen. So although our screen is this big, the hole we cut for it will be a bit smaller. So in the next part we'll be going over booleans and how they work, and of course in Maya booleans are not excellent, so in some cases how they don't work, but I'm sure we'll be able to sort that out. So again, thank you very much for watching. I hope this has been of interest to you, and I shall see you in the next part. Okay, welcome back. So before we continue with making our support pillars for this board, so it's not sort of floating in midair and drilling holes through things and cutting screen holes and whatnot, let's do a quick sanity check. Let's put this together and make sure it is indeed all fitting snugly and nice, which it definitely appears to be. I also want a quick measurement on how wide this thing is going to be, because obviously it can be quite difficult to tell when you're around in the 3D view what the real world thickness would be. So I have a bunch of other design meters. You could also, if you were designing something you didn't have, look up online to make sure you're in the ballpark. You want to get your designs approximately the same as the ones that already exist. You're no point designing something that, you know, feels like a brick in your hand. So let's do a quick measurement here. I'm going to go to Create, Measure Tools, Distance Tool, and click, click. This will be a very sloppy measurement, but it's around 21, 22 millimeters maybe, which is absolutely fine. These cases and this sort of thing for this kind of instrumentation are normally between 20 and 40 millimeters, so we're smack on the ballpark, which makes me very happy. So we got our cases. Let's just hide the front because we don't need it at the moment. And the first thing we want to do, if we look in our view here, and our image plane has completely disappeared. Now Maya has a habit of doing this. If we click on the image plane, you can see it should be visible in all views. The alpha gain is not turned all the way down, and it's just disappeared. So if you flick it all views and then back, it comes back. Now I don't know whether that's a bug in this particular version of Maya, but it's been doing this to me a bit. So again, if that happens to you, just flick the view. It normally happens when I load and save a file. It's not really a big deal. Now what we need to accomplish is to drill 4 holes in our circuit board, and we need to drill them at a fairly accurate size. So I'm going to put an M3 screw through this hole. So I want a 3mm hole. So really the manufacturers of this board will probably have this hole slightly bigger than 3mm, but let's test that. So let's create, first of all, just a polycylinder up here. Let's go to the channel box and its inputs. We want a radius of 1.5, which will give us 3mm, and why do I see 2 interspersed things there? Okay, why am I seeing a... Okay. It's just me then. Alright, fair enough. Sorry about that, folks. Right, let's rotate it round, hit E and J and flip it 90. Aha! I'm on X-ray. That's why I'm that's why I was a little confused at the view I was getting. Alright, but we know this is 3mm now, so we can move it down to here and see. We hit F to line up precisely. And we can see that this was obviously designed as a 3mm hole. There's a little leeway either side, and that's perfectly fine. Now we need to duplicate this 4 times because we're going to actually use this object to perform a boolean in Maya to cut a hole in the circuit board itself. So if we hit Ctrl and D, we will duplicate, but we will lose the input connections. I'll show you. I'll hit Ctrl D, no input connections. So if I want to scale this thing now, I have to use the scale tool, which for us could be a little inaccurate. I prefer to have those input connections available to me. So I'm going to duplicate special, so just edit duplicate special. I'm going to pop open the options box. I'm going to reset the tool, and all I want to do here is make sure duplicate input graph is selected. This way, when I duplicate, you'll see I still have my input graph. So if I need to change the size at a later date, that should be perfectly fine. Now I'm going to zoom in here. I want to be particularly accurate with this. Obviously if your holes are in the wrong place, your project's not going to work at all. Now I need to put the 2 holes up here. So once again, edit duplicate special to preserve the input graph and line these up. Now these should be a pretty close match. These cheaper circuit boards are what I'm working with here are never exactly what you would call stunningly precise. So if you find that, like this one here is maybe a little much to the left, but it should be within the tolerance margin of the extra room around the holes. So I'm just going to leave that where it is. Now I've got these things, I can actually use them to poke a hole in the circuit board. Now what I want to do before I do this, if you use an object in a boolean operation, in a difference boolean operation, that object will appear to disappear. So I'm going to select all 4 of these. I'm going to make them a little longer to start with. So I'm going to come in and just bring the height up to say 20 so I can see what I'm doing with them. I'm also going to duplicate them. So I'm going to hit edit duplicate special again because I want them with the input nodes, and what will happen is once I've cut the hole in the circuit board, I can then use these to perform the support pillars in exactly the same place. So let's just move these here. All of these are for a boolean operation, so let's just put ball after them so we know what they are. Let's call this sup1, and I don't know why I've got that in there. Ball, and then I'm just going to copy and paste that to the other 4 cylinders. Now if you're wondering why I'm naming these when they're going to disappear, I shall show you. So take all 4, make sure they completely bisect the board here. I'm also going to select the board and just hit Control and 1 to isolate it in the view. So now I've got my board and my drill holes, if you like, the things I'm going to use to drill the holes. I can perform a Boolean operation. Now, Boolean operations in Maya are highly dependent on the selection order. So what you want to do is, if you're going to put a hole in something, you want to select the thing you're going to put the hole in first, and then the thing you're going to use to make the hole. If you do it the other way around, let's just do it so I can show you. I'm going to go to Mesh, Booleans, Difference. You'll find you'll put a hole in the, in our case, the thing we wanted to put the hole through. So we got it the wrong way around. So order of selection is important. What you select first is very important. So all of these duplicated cylinders we have here, I'm just going to hide them for a second so I don't select them by accident. I'm going to select this one first, and then I'm going to select all of these, and I'm going to do a difference boolean. So mesh boolean difference, and you'll see I've got the 4 holes. If we confirm in the 4 view that we're in the right place, you can see we're in exactly the right place, so we're good. Now, Boolean operations in Maya are not good compared to something like Rhino or SolidWorks. They have more of a tendency to error. You can use them, and they leave behind, more importantly from a Maya artist perspective, they leave behind hideous geometry. This is a huge n-gon. No CAD package will care about this. This will be the geometry that comes out of a CAD package. It just won't care. It's not in any way important. But I can tell you from a Maya perspective, working on television and film, working with animations, this would be no good, but in our case, Booleans are working out just fine. Now, if we look, you'll see all the Boolean objects appear to have disappeared. Appear to have disappeared. That's a hell of a sentence. But they're gone. But they aren't. What we've got here is group nodes with empty transforms. Now, the reason I named all these things bool is so I would know that they're not empty groups, that they are actually Boolean operators, which means if I select this one and move it, I can actually move the location of the hole. Now, this might come in very important later on if you've made a mistake. If you have just got lots of empty groups with transforms lying around, you're going to run into some serious problems. So I'm going to leave those where they are for right now. I would normally be a bit more organized, but again, I don't want to spend too much time in my own outliner here, so I will leave that to you. What we need right now is to put the support pillars in, so we can use the duplicates that we hid earlier on, and all we need to do is move these up until they support the back of the circuit board. So this can be a little tricky to see. I'm going to do it in this view to make sure we have the accuracy on it. Okay, there we go. Now, a couple of things with these support pillars. They're too long for a start, but that's not so important right now. The other thing is we need to screw a hole through these. So we'll need another set of cylinders where we can put the hole. The other thing is, if we look at the circuit board itself and one of our support pillars, there's not actually a lot of material support in the circuit board. I mean, these pillars are basically the same size as the holes going through, so in this case the circuit board would just slide up and down on the pillars, which is not really the thing we want. So let's take all these pillars. Because we duplicated the input graph with them, we can of course make them a bit fatter. Now again, because I'm going to use these and I still need to drill a hole, I'm going to duplicate them not with Control D, because that would take away the input graph, but with duplicate special, so I have something to drill the hole after the pillars are in place. So it's a kind of layered operation. It becomes more simple after you've done it a few times, but basically if you intend to use something for a Boolean operation, make sure you have a duplicate of it in case you need it later on. So let's take these and let's make these bit thicker, because they're going to get a hole through them which the screw needs to screw into. They also need to be able to support the circuit board, and they need to be thick enough that when we drill that hole through, we're not trying to support the pillar with 0.5 millimeter of material. So let's come in and we'll change this to 2.2 maybe, and you'll see they get a lot thicker. So if I move this one through, there's actually a lot more material here to support the circuit board, which is what we want, and there's probably enough material here to support having a screw hole through it as well. In fact, because I have the room, and if you have the room, it's important to look at the back of your circuit board too and make sure you have the room. I'm going to make these just a little bit bigger, so 2.4 I should think. You know, I have the room for it. I'm not at a tight tolerance, so I want to make them as strong as possible. So these are the cylinders we're using, and these are the cylinders we're not, so let's hide those to make sure we don't select them by accident and then end up with the wrong size pillars. Now I'm going to combine these pillars, so I'm going to go to Mesh, Combine, and that makes them all one object. That means when I select the vertex, I can select all the vertex at once, and I can pull these vertex up until they just bifurcate the back of the case. So as I've probably mentioned with the battery holder, if you have a object in Maya that is intersected with another object, when you come to 3D print this, it will actually see it as all one object. So we don't need to bother with a union boolean or anything. This will be absolutely fine for 3D printing. Now we need to make holes in these, so I'm going to separate them again. Mesh separate. There we go. That should have separated them out, and I'm going to use the copies that we made to bore the holes. So Shift H to unhide them, and you should see we have the copies, but the copies are perfectly central to where we want to drill the holes. So as we're going to use these copies right now, we're going to go to Edit, Duplicate Special, and again we're going to keep a hidden copy just in case we make some mistakes. Now these things should be smaller than 3mm, because we want to use screws that self-tap in, so they actually bite into the plastic. Now instead of making them 3mm, we could make them say 2.8, making the radius here 1.4, and we can now use these to drill holes in the support pillars. So move them backwards, make sure they completely bifurcate the support pillars, select your support pillar. Now we should go ahead and call these ball, just so we know that they're Boolean operations. Now again, I normally spend a bit more time naming things than this, but for the sake of brevity, so we're not all here for an hour, I'll just do it quickly. Selection order becomes once again important, so edit. What we need here is a mesh boolean, of course, and difference. There we go. And you should see our support pillar now has a hole in it that goes right through. It's slightly smaller than the 3mm hole here, which is absolutely fine. It's exactly as we want it. And I'm going to pull this up, and you'll see that it still has lots of support material on it to support the back of the circuit board. So just go ahead and use G to repeat the last command and boolean all of these things. Okay, so we are done. That would act as a support pillars. Now 4 screws can go through here, and you are almost done. However, because we're 3D printing, and you know, me personally, my 3D printer is not like the best in the universe. I like to have some extra support. So what I like to do is provide some little support pillars around the base of this to help stabilize it as it's printing. It also helps to create a stronger bond with the case. So let's do that. Let's disappear into the 4 view here. Let's create a box to act as a support pillar, and what I'm going to attempt to do here is select my cylinder and hit Ctrl+1 to isolate it in the view, which it doesn't seem to want to do for some reason. Let's see. There we go. Just a small hiccup. And the reason I want to do that is because I want to create a small box, and that will have come in the center of the grid. So let's make this small box just 2mm in all of its dimensions. Now let's move this up here, and I want to get this so it's kind of bisecting this cylinder, and I want to get it pretty central. Now for this, I don't need to be terribly accurate. Anything bisecting is going to print as one object. Now this is probably quite big. I should use 4 of these, I should think. If we go back, you can see them here. Now this is probably too big. It's probably overkill. It's probably too thick, so I'm going to make the thickness 1mm. That's the wrong one, of course. There we go. And that looks a little better, and I might actually make the depth 3mm to make it a little higher. And now we can have some support columns going around the base of our pillar here. So let's come in, and rather than duplicating these 12 times and manually arranging them into space, all I'm going to do is select it, go to Edit, Duplicate Special, and I'm going to duplicate it around its pivot point, which means I need to move its pivot point. So I'm going to hit Insert on the keyboard, and I'm going to move the pivot into the center of the cylinder. There we go. That's going to be about central enough for our intents and purposes, I would have thought. So let's take that and go to Edit, Duplicate Special, and now I need to work out how many copies I want. So I'm going to reset the tool completely. I am going to look at how many copies I want, so probably 6 would do. 1, 2, 3, 4, 5, 6, yeah. So then we need to create 5 copies because we already have one. So just down here, number of copies, 5, and we need to give it a rotation. So it'll be 6 divided by 360, which should be 60, I think. My old brain here, Duplicate Special, there we go. So that gives us this little support structure around the pillar, which will help this become more stable and will 3D print a bit nicer. Now I'm going to take all these and I'm going to group them, and I'm going to call this pill support. And then I'm just going to duplicate it and copy it across to all the other instances. So let's hit Control 1 to go across, and we want to a nice duplicate of this. Where is it? There we go. Now this can be duplicated without its input connections. This cube also needs to go in the group, so middle mouse drag that in there. I'm going to turn the X-ray off here so I can see a little better. Actually that doesn't help us, does it? And just hit Control D. I'm going to center the pivot, and I'm going to move it so it's on here. Now this is a little difficult to see. Let's try wireframe unshaded. There we go. And I'm just going to make sure that all of these are bisected. This really doesn't have to be too accurate. Control D, and again just come down here and do the little support thing. Control D, come down here and do the little support thing. You might want to take a bit more time and effort getting a bit more accurate, but that's perfectly acceptable for me. And now if we hit Control and 1, you should see you've got your pillars with the supports round. They're not interfering with anything else. We got plenty of room for it, so why not? You could even make them, if you wanted to, a bit higher. I think this is going to be enough in my case. But that's good. So now we've got the support pillars in for this, we need to attach the front and back of the case together. So we'll need to actually drill some holes in the back of the case, and we'll need to provide some room for the screw head to tap in so we don't have horrible screw heads sticking out through the back of our case. But we will tackle that in the next part. And I think we're almost close to finishing. After that, we just have to punch the holes through the front of the case, print it out and make sure it fits. So I'll see you in the next part. I hope you found something in here that was useful to you, and thank you very much for watching. Hi, welcome back. So we've got our mainboard here securely fastened to the back of our case, and we've got somewhere to hold our battery. Now what we need to do is find a way to join the front and back of the case together, and I'm going to do this with my rather crude representation of a screw here. We're going to need to screw through this case all the way into the front of the case here. Let's just find it and bring it back and join the two halves together. Now what we don't want to end up with a situation of screwing through the case and having the head stand proud. So we don't want this. We don't want this. We want the head to come all the way through the case and be recessed into the case. Now in order to do that, we'll need a receiving hole to receive it. Now our screw is an M3 screw, the same one we use to mount the same size we use to mount the mainboard, which means it's going to have a head circumference of around 5.5 millimeters or a diameter of 2.75 millimeters. So we need something wider than that on this side to receive it. We're also going to need to punch a 5mm hole through the case itself. So first things first, let's create something to receive this. Now I want an extra 2mm of plastic around the nub that's going to receive the head, just to give it a bit of strength. So I'm going to create a cylinder at 3.75 with a radius of 3.75. So let's go 3.775, and this will be the thing that receives our head. Now the head will be screwed 2mm into the plastic through the case, and then we're going to have to see how far we want the head to protrude in here. Now for me that should be around 5mm. So the head will protrude a total of 7mm into the case. So I'm going to hit E to rotate this, and J. Now the head will protrude 5mm into this nub, 7mm in total, which means we want some excess plastic on the top of this. And as we've gone for a 2mm thickness all around, I'm going to go for 2mm again, and I'm going to make this 7mm. So let's make it a height of 7mm. So basically on the back side of our case, whoops, that was the wrong axis, on the back side of our case here will be a 7mm nub in which the screw head will sit. Now if we were to extend that outwards, there's a chance it would interfere with this, so we're actually going to have a shorter cylinder on top to receive the body of the screw, the actual screw thread itself. Now we can get rid of this demonstration purposes screw. We need to find somewhere to put this. Now this would be where we screwed the case together, so the ideal scenario, let me just hide the back of this here, Control and H, and the ideal scenario would be to put this right in the corner. But if we did that, it's going to end up protruding through the bevel, and I think it's going to look awfully ugly. So I'm going to find a place for it where it won't protrude through the bevel, but also it's not going to interfere so much with the inner bevel either. So I really want to get this down here. Okay, so somewhere around here. Now obviously that's going to interfere with the case, but as I said, we're going to extrude a narrow cylinder out of this, or add another narrower cylinder to it. Now we need to get another one of these exactly at the same point on this side of the case, and I'm just going to move that down so it doesn't interfere with this inner bevel at all. There we go. I don't want it too close to the edge. That should be fine. Now there's an easy way to duplicate this so it ends up at exactly the same spot over this side. Now like I say, in an ideal world I'd have it more in the corner, but I think this is going to be close enough to make sure the case seals up nicely. So let's come over here. Now looking at this in this view, let's add the final radius of the final tube. So the final tube to receive an M3 screw is going to be 2.8mm in circumference, so 1.4 in diameter. So let's create a screw and make sure it fits over the screen. Nothing worse than getting this all set up only to find it doesn't fit. So let's give it a height of say 20 here, and a radius of the final radius would be 2.8, so I'm going to make it 1.4, so I'm going to make it 2.4, because when we bore a hole in it we also need to have enough plastic left on either side of that hole to be able to support the hole. Then I'm going to move it up to the center of this where the head would be received, and we find that here we are, we're still bifurcating the screen assembly. So we could move the screen assembly down. I don't particularly want to do that, so I'm going to grab both of these together and find a place for them where this does not intrude on the screen or the bevel. So around here should do just fine. So now we've got an idea of what we're dealing with, and it's good to mock these things up, you know, because we could have started to cut holes in here only to find that they were in completely the wrong place. So I'm going to take this and I'm going to duplicate it across so it's in the same position on that side. So let's go into this view. Let's select this here, and how we're going to achieve this, the central line of our grid is actually the central line of our object. So if we move the pivot point of this over to here, we'll be able to mirror it across on the other side. So let's hit insert, let's hold X to lock to grid, and let's drag this along until it's in the center. Whoops. And I clicked on a edge, so of course it's now aligned itself to the edge. I'm just going to Control Z that. I'm going to hit insert to stop moving that, and you'll see when I click on it, there it is. So now we just need to mirror it. So we're going to mesh, mirror. I'm going to pull up the options box for the mesh tool. I'm going to reset it. I don't want to cut the geometry. I do not want to combine with the original. And our axis here is X, as you can see, and it's negative X going this way. So that should be fine. Bang, mirrored. So now we have those both on both sides. Now I'm just going to select them both and push them through the case, because I want to see how that would look on the other side where the screws will screw through. So that's not ideal. They should be further out this way. Is there any way to fit them further out that way and still retain the integrity of the plastic? In this case, I think not. I'd rather have more plastic and have the fastening screws a bit further out, I think. Let me just take a second here to see if there's any way we could adjust all this. See, the problem is if we move all this downwards, which we could do because we still have the Boolean objects. In fact, we don't need the Boolean objects. We could just literally grab this and push it downwards a bit. Is that going to be worth doing to have these screws? But that would then adjust our battery downwards and we wouldn't have room for our bottom plugs. So is that a disaster? No, it's not. Okay, so we know that that's not going to correspond with the bottom of this. Let's just double check. No, that's not going to strike the bottom of that. The tolerance is going to be tight, but it should be enough. Okay, so we need to now cut, because these objects will be receiving the screw head, we need to cut a 5.5mm hole through the case. So let me move those both at the same time so they're both in the same position. And there we go. We need to cut a 5.5mm hole in this case. So I'm going to take this, I'm going to delete it, I don't need it anymore. I'm going to duplicate these because these will become Boolean objects in a minute after I've resized them. So edit and duplicate special, here we go, and yep, duplicate input graph, duplicate special. That has given me a cylinder under a group node, which probably happened when we merged it, when we mirrored it, sorry, it probably appeared under a group node. So just pull those out the group with the middle mouse drag, and I am going to hide a pair of these. So control click, control H, so we've just got them hidden. Let's just move those together. And I'm going to now make these 2.75, which corresponds to 5.5mm, of course. And I'm going to use these to punch holes in the case. So I'm going to select the case, hit Control 1 to isolate the selected view. And we're going to have a small issue here. So what's going to happen is I'm going to punch a hole in this case right now. So let's make sure that's completely bisected. I'm going to select the thing I want to punch the hole in. I'm going to select the hole punch. I'm going to go to Mesh, Boolean, and Difference. And that's going to punch a hole in the case. And everything looks great. That's where I want my 5.5mm hole, and that's precisely where I've got it. Until I do this, and I smooth it. Yeah, in which case, you know, forget about it. Yeah, that's just horrendous. Now, there is a way to combat this, and I'm going to show you why it's going to go a bit wrong also. So let's just, for the time being, just isolate the back of the case itself. Right, and let me show you what happens. So we smooth our case, it's not too bad. Okay, it's absolutely fine. However, we know if we boolean it, the hole is just simply not going to work. So we can convert this view. So we can just go to Modify, Convert, to Smooth Mesh with Polygons. And now, if I hit 1 on the keyboard for no smoothing, it's exactly as we want it. And now I could cut a hole through the back. But look, this geometry here is horrendous. And if I wanted to change it at a later date, it would be very, very tricky. Now, we could work with this. I personally hate it, but we could work with it, but we don't have to. So let's undo the mesh smooth on this and look at another way of doing this. Now, we know that we definitely need to smooth this. So an easy way to sort out a problem like this, if you've got these big giant faces, just delete them. Right, so we've got no front and back thickness anymore. If we hit 3, it smooths out just nicely. We can now modify, convert, smooth mesh to polygons, And there we go. We've got a nice smooth outer part of our case. Let me take off the wireframe unshaded. Now we're dealing with more geometry. And if I want to, which of course I do, I can come in, select the outer edge here, double click to select the whole edge, and then just go to Mesh, Fill Hole. Okay, now we've got a smooth case without the horrendous geometry in the middle. And if you've got horrendous geometry like that, Maya's Boolean operations are not perfect. They're certainly not as good as CAD programs, so you may run into problems. We don't need it. It looks horrible. It could cause problems, so we do it this way. It doesn't take very long, and we get a much better result at the end of the day. Now you'll probably find where you've added these edges, they're what's called hard edges. It doesn't really matter in this intents and purposes. You can always select the edge and go to Mesh Display Soften Edge, but it's really just a visual thing. As you can see, a hard edge going around here. So in this instance, it doesn't bother us. We've got the smoothing we need, we've got the case we need, we know this is perfectly flat because it's one face. There's also a huge end gone, but once again, in this instance, that doesn't really make much of a difference. So I'm going to select this. We've now got our nubs through here. These should be our 5.5mm holes. Let's just verify that. 2.75 they are. Let's bisect this one also. Okay, and let's cut the holes. So now we don't need to smooth, because this is the unsmooth view now. So I won't have the same issue. So I'm going to select this, mesh, mesh, boolean, 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 boolean. In fact, what I'm going to do is I am going to make this, whoops, let's not select both of those. So these cylinders are 7mm. That was right, wasn't it? So let's duplicate these and make, actually let's just make the holes in the back first. We do have a spare set of these cylinders, I believe. So yeah, let's just make the holes first. So mesh, boolean, difference, that should punch a hole through the back here. And the same thing again, just hit G and you'll repeat the last command, of course. And now I can pass a screw all the way through the back of my case, as you can see. And it should be the same size. Yeah, I think we can see without me lining that up perfectly. The problem is, as I said before, if I continue to pass it through, it's just going to fall down on the floor and we're all going to look like we're a bit thick. So that's obviously not good, which is where these cylinders come in. These will be the receiving cylinders. So let's unhide them, and there we go. Now we know that these cylinders are 7mm. We know this is 2mm, and we know we want to be left with 2mm of plastic. So if we make a 5mm version of these, this will make sense in a minute, I can assure you. So duplicate special, edit, duplicate special. There we go. And if we make a 5mm version of these, and we adjust this to the back, so that's 2mm through the case, and then it will be 3mm through these. These are 7mm, I believe. So these should be 5. That will allow the screw head to recess 5mm in. Yeah, that sounds about right. Warning, math, although very simple math. Still, my tired old brain sometimes has trouble with that. Yeah, that'll leave 2mm of plastic on the top. So let's select both of those, make them 5mm radius, so 2.75, and use them to punch holes in this. That will leave us with a screw that goes 5mm into the case, and also 2mm of plastic on here to give us some extra support when we bore another hole through it. So I'm going to select this, I'm going to select this and this actually, and duplicate special. Anything I use for a Boolean operation I want a copy of, because it's going to disappear in the Boolean operation itself. So if I do this, and like I said, the booleans are useful because you can use them to move later on. So I'm going to make sure I select this one, and mesh, boolean, difference. And you can see here, I now have room for my screw head to go 5mm into the case. Although why? What? Those should be exactly the same size. And are they? It's very difficult to see in this view. It didn't look like they were, but they may well be. So let's see here. Okay, what am I looking at? I think they are exactly the same size. Let me just move this. Yeah, it is exactly the same size. Okay, oh, I see. They weren't bifurcating the back of the case. That's why. That's not a size difference. That's a lip. So we need to select this and make sure it does actually bifurcate in the back of the case, which means my lineup was wrong, so I need to undo my boolean. Okay, better to know now. So make sure our 3D printer sees these as one object. We need them to go into the back of the case like so, and now we can perform our boolean operation. So select this one, mesh, boolean, difference. Same with this. So this one, mesh, boolean, difference. And there we go. Now you can see that they're the same size, and we have room for our screw head to nuzzle all the way into here, not making us, you know, look bad with our screw head protruding somewhere out here, like we have no idea what we're doing. It'll nuzzle neatly in there, and the screw will go through, and we'll be left with a small hole on the back that we could even make a plug for should we want to. Now, of course, the front of this has no hole in it, but we'll be taking care of that in a minute. And what we need is to do this again down the bottom. Now these we can move to a more outward location. So we'll just need to repeat the process. Now normally and in fact I can use edit, duplicate special. I can use these two as kind of guides here. So one, actually I really only needed one, and they should be bifurcated because that should have been perfectly flat. They indeed were. So I'll just use one because I'll mirror one across, and this I can get much more into the corner, which I like. So let's use wireframe unshaded, makes me happier. There we go. And I'm going to use the same trick of mirroring this across. Now let me just go here. So let's adjust pivot point. Wrong view, of course. Hit F to zoom in on this, and insert to move the pivot point, and X to lock it to the grid, and whack it out here. And then because we let's just hit insert again, because we've done this once before, the mirror command should be the same. It is done. I mean, it should have the same options on it. So now we know where we want these holes. What we're going to have to do though is we have no duplicates to cut the 5mm hole in the back of the case. So I'm going to make some. So we know it's going to be a 5mm hole. Let's get a cylinder. Let's make that cylinder 2.75. And let's move it down. We're going to have to line it up manually. It's not such a big deal. There we go. Is that actually 90 degrees? No, I can see it's not. There we go. And I'm going to use this view to centralize it. So down here, over to here. Hit F to zoom in, and we want to get this pretty close. Okay, I don't think you're going to get it much closer than that. So that is good. Now we can use the same trick to get this one over to here. So let's select our smaller cylinder, if I can find it. There it is. I'm also going to make this a distance of say 10, sorry, a height of say 10, just to make it a bit easier to see. This is what we're going to use to cut the hole through the back of the case. So I'm going to center its pivot here, insert, X, drag it until it's in the middle, and then I'm just going to mirror it. So I'm going to insert to get off the pivot point, mesh, mirror, and then it'll be over there, and then I can use these two to cut a hole through the case. Now before I do that, I want a duplicate set down here. So mesh and edit and duplicate special. There we go. There is our duplicate set. Let's use these. Let's double check that they are the right size. They will create 5.5mm holes. So first off, let's bore through the case. Okay, so procedure we've seen any number of times. Select this, mesh, boolean, difference. There we go, give it some time to calculate, because it's got a lot of history and a lot of smoothing on it. We'll deal with that in a second. And this one, and this one. Oh, wrong way around. And G to repeat the last command. Give it a second, and we should have the holes in the back of the case down here. So we'll have 2 screws that go in up here, and 2 screws that go in down here, which should fairly well hold the case together. Now, we need those, what do we make them in the end? 5mm, I believe. So let's go 5mm. That way we can shove both of them out here, align them with the back of the case. Now you'll notice I'm not being too careful with this. You don't need to be for this. And these will need to be 2.75, yup, same size. I'm going to get a duplicate copy of these as well, because I'll need them later on. So mesh, edit, I don't know why I keep doing that, duplicate special, and move the others out. Select this one, and mesh, boolean, difference, same procedure. Oops. That would be a bad thing. G, and there we go. So now I've got room to receive my screw heads on the bottom here and the top, and all I need to do is create a pipe that goes from here to the front of the case and then bore a 2.8mm or maybe 2.7mm hole through these so it can receive the screws. But as I say, that makes a nice neat job of pushing our screw all the way into the case. So when we screw it together, we don't have a giant screw head sitting out here. We also have our duplicate objects waited to be used for booleans or whatnot in exactly the right places. And we're pretty close now to getting this to a point where we can actually screw the case together. Now, when we come back, we could actually put some extra little supports around here. It's not really a difficult thing to do. In fact, if we just duplicate this and I move this up here and this here, because I'm not going to boolean this into the case at all, it just needs to bisect. It doesn't really bother me that it goes through the inner bevel. You're not going to see it that much anyway. So if I select this, if we go into the view here and come up here, I am just going to make sure it's pretty central. I'm going to hit insert. I am going to move its pivot point to the center of this thing, like so. That should be about right. Let me just go back in selection mode and move it so it's pretty central. Then I'm going to go to edit. Where are we? Is that embedded enough? Yeah, it is. Edit, duplicate special, and instead of duplicate input graph, we are going to just reset the tool. Just to make sure we're all on the same page. Number of copies 5, and I believe we'll need that to be at 60 degrees to make a full circle, and there we go. And make sure that that's all bifurcated. It is. We can then take all of these things, including the original one, Control G to group them, and that group has appeared where exactly? Under PCB mount, pill supports. Okay. So which group was it? Okay, group 1. Yoinks! So we'll call this one case screw. What would we call it? Support. I'll come up with a better name. And then we just need to duplicate this group and stick it around all of our objects here. We want to make sure we can now center the pivot. So modify center pivot so we can do this a bit easier. Want to make sure we've got all the bifurcations so the 3D printer shows it as one object. It does. Then we want to duplicate it again, for which we can use Control D, and then we want to do the same thing on the bottom supports here. F to focus the camera on. And there we go, pretty good. And once again, Control D, and let's move this across here. F to focus the camera, and make sure they're all bifurcating. There we go. And we are done. So now we've got all the supports ready to receive the screws through the back of the case. In the next part we will finish off by boring some holes, creating some receiving cylinders on the front and back, and then we're going to have to look at cutting all the stuff out of the case. But so far we've done pretty well. We've got a main board secured, we've got the receiving holes ready, we've got everything with little reinforcing nubs around it. You know, maybe these could be a little higher, that's entirely down to you. I tend to think that we have left a fairly generous allotment of plastic, and it depends on what you're printing in. But for me, this should be absolutely fine. So thank you very much for watching, and I shall see you in the next part. I hope you found something useful. Okay, so welcome back. Now we have our little holes in the back of our case and the support nubs to support the head as it goes through the case. We need to make the actual holes and the support pillar for the screw itself. So as we know, the screw thread is 3mm, so we're going to make the diameter of that 1.4 to make it 2.8. Now we're making it slightly smaller, as I've mentioned, so we can use self-tapping screws to screw into it. So let's select all 4 of these and duplicate them, because we are going to eventually need to use some Boolean objects here. Let's just make sure all 4 of these are in the right place, and I've actually missed one in the selection. So we don't need them to be straightened up, that's absolutely fine. Let's just make sure those are central and the bottom ones are central. Yep, they are. Now, how we're going to do this is we're going to create, first of all, a tube that the screw thread will go through. So that tube is going to be, let's see, 2.75 makes it 5mm. That's too big. Let's make it 2.4. Okay, so that should have sized those two. Did that size all of these? No, let's make this one 2.4 as well while we're at it, and this one should have also sized down to 2.4, 2.4 and 2.4. This will mean we can put a 1.4mm diameter hole through these, and they will have plenty of plastic either side to support that. So let's bring these out and just sit them on top of here. Now we just need them again bisecting, and we want to make the length sort of the same distance as the outside of the case. So to do this, I'm going to quickly join these two together, so mesh combine, and I'm doing this just so I can get at both sets of vertex at the same time. So if I come down here, it'd be easier to see. I can select this and hit W and move both sets of vertex back. Now we want to get this pretty accurate, so I'm going to zoom in, use a bigger view, and move them back. There we go. So that will be where the screw thread actually bites in. So we need to put 1.4mm diameter holes in here, or 2.8mm circumference holes, and we need to do the same on the other side. So let's bring the front half, finally bring the front half of our case back, and we'll need to do the same thing with these ones down here. Now probably would have been better off doing this all at the same time, so my apologies there for the inefficiency, but it shouldn't actually take too long. You'll see if I do it without combining, I only get 1 set of verts at the same time, and that just leads to twice as much potential for error. So vertex, let's swap the view, hit F to zoom in here, there we go, select both sets of vertex and move them back until they're level with the edge of the case here, so somewhere around there. Now you want to get that as accurate as possible, so spend a second lining it up if you need to. Okay, that's done those. So our screw will now come straight through. The head will stop around here in the case, so it will be nicely in there, and we need to punch this 2.8mm hole through this piece and this piece. Okay, but before we do that, let's bring the front of the case back and sort that out. Now, we are going to have the same issue on the case front, so Shift H. If I smooth this, move it over to here, you'll see it fits perfectly, but when we try and punch holes through this, we're going to have the same problem we ran into last time. So let us go into unsmooth display and just delete this face and this face before we punch the holes. Let me just shift delete, and then 3 for smooth mesh preview, and then convert that smooth mesh preview to actual polygons. And there we go. Now we need to replace our faces, making sure we are indeed in object mode. Let's select the edge here. Make sure I get the right edge, because getting the wrong one would be bad. There we go. Double click and mesh fill hole. There we go. And same on the back. And I selected the wrong edge. And I believe I selected the wrong edge again. There we go. Zoom and mesh fill hole. And there we go. So now we don't need to smooth this anymore because the smooth mesh preview has been converted to polygons. So now we are good to go to punch holes in this. And how we need to do that is to take these two pieces here and these two pieces here and mesh duplicate special. Where are we? Sorry, edit duplicate special. Doink. And we should be able to... Oi! Oh, okay. Our duplicate special settings were still set to duplicate around a circle, which in this case is not going to do us any good at all. So duplicate special, we want the options box. Let's hit that. Let's reset the tool and duplicate input graph, duplicate special, and now we should be able to just throw these in here. Now we do not need to punch any holes through the front of this case, simply because we don't want to in this particular instance. Now we need to come out here and we need to select these and have them go to the inside marker of the case this time, not the outside. That way they should marry up when we move them over here. So let's combine them, all objects together. So mesh combine, just so we can do this all at the same time. And yep, sometimes Maya has a little conniption where it doesn't actually combine the objects for whatever reason. It's not feeling like it on that particular day, I assume. Let's Control 1 and isolate the view with just those 4 objects. Let's get a vertex. Luckily enough, there's not that many vertex. Let's pull them out so we've got something to work with. Let's unisolate the view, Control 1, and let's line them up with the front of the case. So I'm just going to middle mouse drag these, and I'm going to get them as close as I can. There we go. That looks about right. Now, let's move the front and back of the case together and see if those line up. No reason that they shouldn't. So in order to do that, I'm going to select all of these. I'm going to select this, and I'm going to hit Mesh, Combine. Actually, I'll just group this. I won't combine it. So in order to do that, I'm just going to hit Control G. Oops, I lost my selection there for a second. Control and G, center the pivot, modify, center that pivot, and move these over here. Let's get the case shut up. So we want a fairly tight seal on it. So somewhere like there. Actually, probably be easier to see in this view. There we go. And if we look at the top of this under X-ray conditions, you should see that our shafts match up. So is that actually matching up? This is honestly become quite difficult to see. Let me just turn off X-ray a minute, make sure that's lined up. Okay, I'm going to go into the group node here and just select the cylinders, and then I'm going to go shading X-ray, and I believe those are overlapping these ones. Let's select those ones. So Control hide this part of the case, and then come up here and select these guys. Yeah, they're overlapping, which means this is a fairly simple fix as it happens. So let's show the case front. This is the case back. So let's move it, freeze its transformations first. So modify freeze transformations. That way if you move it out the way, you can move it back by just zeroing everything. So we need to see what's happened here. So that and that is massively overlapping, and I think I probably know why. Let's select that and that. Let's go to Control 1, and rather than adjusting these edges, let's go here. Oops. I need to shift select so I can Control 1 down here too, and then switch this to X-ray. So rather than going for these edges to the outside edge, we need to go to the inside edge, which is going to be a bit more tricky, but nothing we can't handle. So vertex, zoom out a bit here, maximize the view, select all of these vertex, and then I'm going to move this in till they are equidistant with the inside edge, which I believe is there. Okay, so let's do that. And now we can look at these screws. Right, so that seems like that's a little bit off. Let's just make it a little bit short. Just give ourselves that tiny bit of margin for error in the printing process. I mean, we're talking of fractions of a millimeter here. So that looks pretty darn good to me. Alright, now I can bring the case back, which should be up here. Okay, there it is. I actually didn't hide it. So as soon as I move this to 0, everything should line up in its proper place. Now we'll be able to put a screw through here, and it will be received into the head there, and it will screw into the plastic on the front here. So let's take this group and move it out. Okay, and we are done. So what we need, however, is the holes to receive the screw thread, because this will be solid plastic at the moment, as will this. So this is going to be an easy one. Let's select all these 4. Let us separate these, mesh separate. They should be all now separate objects. They are. Now we can duplicate special, change the diameter, and use them as drills to kind of drill through our plastic here. So let's go to edit, duplicate special, and make sure that we're duplicating the input graph. Duplicate. Right, let's move these slightly. In this case, I don't want to drill all the way through here. And find the polycylinder. This needs to be 1.4. You might make this 1.35, and these need to be 1.4 as well. Okay, so those bottom ones are just not playing ball, so we must have whoops. Let's hit 6 to go back to normal view, and select these 2. So something's gone a bit hinky here. It doesn't really matter that much. I can't change the diameter of these, the radius. It's not having it at all. It doesn't really matter. I can duplicate this one. So mesh, duplicate selected, edit, sorry, duplicate special, not duplicate selected, center the pivot. And I'm just going to move a couple of copies of these down here. I don't know what happened there. I obviously got some error. It's not terribly important. And we need to centralize this one to here. So this is not a good viewport to do it on. This viewport will be fine. Let's get this in the middle, so that there, and that's pretty central. Now duplicate special once again and move it over to the other side. There we go. If I hit F to race over to there, actually that was pretty almost spot on without even trying. Look at that. Alright, now process we've done many times before, but before we do that, we're going to need to drill a hole in this side. We're also going to need to drill a hole in this side. So let's get some duplicates going. So let's do it. So duplicate special, move those out of the way, select this one, mesh, boolean, difference, and now it's just a case of going around and doing that a few times. And here. Now let's take these ones and move them through that lot and into this lot, and they should match up absolutely perfectly. So I think we're going to need 2 sets for this, because we're going to need to boolean this, and we're also going to need to boolean this. So yeah, we're definitely going to need 2 sets. Now I'm just going to duplicate these because I'm not going to be changing the diameter of them. So Control D, W, out here, 1, 2, 3, 4. I'm going to make them a bit bigger. Whoops. Actually, they shouldn't need to be any scaling done on them. Let's make sure that punches through. It does. And again, just complete the procedure. So G and aha. Wait a second. That didn't look right. Okay, these are joined together. So mesh, separate. Okay, the last command used was separate, so that's not going to work. So we're going to have to mesh boolean difference and make sure that cut all the way through it. It did. And G, there we go. And G, so we're making fairly complicated. That didn't look right either. Because these are also combined together, so we could mesh separate. Okay, so mesh boolean difference, there we go, and G to do a boolean difference. So we got one last piece to punch the hole through, and that's this one. W all the way through here. Want to make sure it's all the way through. Job's a good one, as they say. I'm going to hit just there, and G, and that should be a hole all the way through there. Same thing, this one, and a little difficult to see. G, this one, and you should see the screw hole goes now all the way through that entire assembly. So our screw passes through, gets threaded through here. Our head would stop around here, and then our screw carries on and screws into here, joining the front and back of the case together. Now let us go downwards, and we still need to do these ones. So this one and this one, done, and this one and this one, and done. Now let's look through the back of the case, make sure we can see through it, through all 4 holes. A little bit of verification, never hurt anyone. There we go, so that's the back of the case done, that's the front of the case done. Well, we need to cut holes for the various bits and pieces, but the case should now be screwable together. Now, let's see, do these, so let's find this. PC beam mount, pill supports, that's these ones, let's duplicate them. Do they fit over here to save me doing that again? So let's come in, let's bifurcate. Let's line this up. Not a good view to line it up on. There we go. W. So I need to center the pivot. There we go. And boinky boinkies should be here. Yep, they line up just fine. Let's check it in this view. Yeah, lines up just fine. Give us a bit of extra support around our plastic there. Control D, move it over here. F and F. Let's have a look where we go in. We go in just here. Perfect. Control D. And all the way down here. Over to this one. So F here, line it up. Close enough. And Control D. Shove it over here. F, yeah, it's going around the pipe there, and done. Okay, that gives us a little bit more support. We've got the back and the front done. Now we've got a horrendous mess here. I'm actually going to clean this up in between the parts, and you can come and look at what I'm doing. But for right now, I actually am quite happy with where we're going. We've got our smooth cases here, we've got our front and our back done. What you will want to do is group all of this stuff together. So Control G, and we'll call this is the case front group. That's the case front group, because when you move this around, you don't want to be in a situation where you've moved this and then everything else is out of kilter. So I am going to, in between these parts, organize all this, rename it, stick the booleans in a folder called booleans in case I need them later on, and we'll come back and we'll start doing some of the more fun stuff, which is cutting out the displays, buttons, ZIF sockets, and the banana plugs, the binding posts for the front of this thing. And we are almost done here, folks. So thank you so much for watching. I hope you found something interesting in this and it's inspired you to maybe make something. I hope you find some interesting projects. I will see you in the next part. Thank you for watching. Hi, welcome back. So we're getting quite close to finishing here. I just want to go over some scene organization. So we have the main board, the case front and the case back all grouped. We also have each individual support pillar grouped along with its sub-mini supports. Just makes everything a little easier. All of our Boolean operators and everything else are in a folder called bool. Now at this point I don't really need them anymore. There are ways and means of changing things around. So if I take this, I'm actually going to freeze its transformations here, so modify freeze transforms. That will just allow me to easily put it back in the same place. So if I take this for instance and I needed to move this hole, I can do it with a Boolean operator. I can also do it just by selecting the vertex around it and moving it. So for me at this point in time I'm confident enough to say that I don't need them. So if I set this back to 0, it will now go where it was. So in order to get rid of them, to make the scene neater, tidier, less prone to error, quicker to open, I'm going to delete the history. Now that will also delete all of our input nodes here. So we'll no longer be able to change them here. Now this isn't really an issue for me at the moment because I'm fairly confident everything is the right size, but you might want to go ahead and save a backup of this. Just in case you've made a mistake. So for right now, however, I am going to select everything here, go modify, delete by type history, edit, delete by type history, and that will get rid of the history on our objects. Now our bool folder is considerably smaller. I just want to make sure we don't have any history on these. If we do and we delete them, then everything is going to get, well, it's not going to be a good history. Yeah, so that should be now safe to remove this group. Oops, and in that group was my little screw, which of course I want. Okay, aha, when I selected everything and delete by type, this is what I'm talking about. So I didn't delete the history on this screw, so if I delete this group, the screw itself disappears because its transform node has somehow been transferred in here. So just something to be very aware of. History is gone on the screw now, so I should be able to get rid of this. And now I have a nice, clean, organized environment with which to do my final design tweaks. Now, as I said, if you do need to change something, it's always possible to change it by using Maya's standard tools. It might be a little more tricky, but right now I'm all set up and I'm pretty much ready to go. Now, as a design consideration, I want to mount this PCB, this main board here, to the front of the case as opposed to the back of the case. One thing that occurred to me when I was reviewing my design was we will have posts down here that will be connected to this main board, so there'll be wires going from here to here, and I don't want that. I want to take the case apart and not have it still connected together. Now luckily enough, this is a fairly simple fix. All we need to do is move these supports over to here. Now because we have a nice organized file, we should be able to do that by selecting B1. So this is B1, B2, back 1, back 2, back 3 and back 4, B4, B5 and B6. Now depending on how you've organized your file, you may or may not be able to do it this easily, but for me it's just a case of bringing these over here, making sure that I bisect the front of the case. Now, because we know the front of our case is perfectly flat, you don't have to check each individual one, of course. You just need to go through. Make sure you don't push it all the way through, because that would be bad. All right, now we need to select all of these and move them down towards the front. Now, the easiest way to do this would be to just take B1 here. What else did we have? B4, B5, and B6. And B6, and drag out the actual support pillars themselves. Now, we're going to need to do this anyway because we're going to need to change the size of them. So I'm just going to drag them out into the main section of the outliner here, so they're not grouped anymore. And now I can select B5, B6, B1, B4, and B1. I'm just control selecting. I'm going to center the pivot. Okay, that pivot should not have centered there, and it's because I still have the actual group selected. So you can see here I've selected the entire case back group. That was not what I wanted, and there we go, the pivot is central. So a lot of the times the placement of the pivot point for your movement, if it's somewhere you don't expect it to be, have a quick look around and make sure you haven't accidentally selected anything, so they're all nicely bisected. So now I can move the whole main board group from the back here to the front. Let's go ahead and do that, and we're going to have to adjust the size of these pillars. So our whole main board group, let's bring it down, and actually we know that it's in the right place right now. So easy way to do this would be to join the case halves together again. Now I can't do that at the moment because if I select the case front, you'll see this stuff doesn't select. So let's bung all this in the case front, and then we need to move those support pillars from one to the other. So B1, B4, B5 and B6, we need to move them from the case back to the case front. Done. And now if I select the case front, the whole case front will be selected. So let's center the pivot on the case front and make sure it goes to where we expect it to go. So center pivot, it goes exactly where we expect it to go. And I'm just going to close the case up here. So I'm going to use this view to make sure the case is nice and snugly fitted together, like so. Done. And now if we hide the case back, you'll see that we can easily adjust these to the appropriate length. Now before I do that, I'm gonna want to cut the hole for the screen, and there's a method to my madness here, because I don't actually know where the main board will go. Now I want to put an inner lip or like a bezel around this side of the case, so in the inside, which will adjust where the main board actually goes. So let's go ahead and create our boolean object to cut our screen hole. Now as you can see, our image plane has once again disappeared. Thank you, Maya. And we're just going to do this. Now with our screen, our screen is actually only the lighter bit you see here. So I don't want to just use the screen object we already have. I want to create a new one. So I'm going to come in, I'm going to create a sphere. I'm not going to worry too much about the scale of this because it's going to be done simply by eye. As long as it's more than 2 millimeters thick, you're going to be absolutely fine. So, and then outwards like so, maybe a little taller. Done, and that will be the hole for our screen. Obviously I'm going to bevel it a little bit so it doesn't look, you know, razor sharp, and it's way too fat. So when in cases where you just don't need the accuracy, it's just fine to just come in and scale them out, especially if you know you have accurate reference. So let us just isolate that so we don't have to deal with all the other gubbins, and select our 4 corners we want to bevel. And I'm just going to put a slight bevel on this so we don't have any razor sharp edges, and edit mesh and bevel. Probably be too big to start with, so let's try something like 0.2 and give it some segments. There we go. It doesn't really matter how many in this case, and we have a boolean object to cut the hole in our screen. So if we move this forward and cut the hole in our screen, we will be perfectly lined up, hopefully. Now, another thing, I want to edit duplicate special on this guy, because I'm going to use it as a Boolean object, and I'm going to reuse it to create the inner bezel as well. So I need a copy, and mesh Boolean difference, and that should cut the hole for our screen. Now, we want to create an inner bezel, because if I just grab my main board and push it up against the front of the case here, if I am even a micron out, or 100 microns out, I'm going to be able to see through the case here, and that's just going to look nasty. So what I want to do is put an inner lip around here, a very thin, very narrow inner lip, so when it comes time to put the case together, if I have made the smallest of errors, or my 3D printing is maybe not as hugely accurate as it should be, I've got a nice inner lip I can just quickly sand down to exactly the right dimension. So in order to achieve what we need, we'll need to have something this size but thicker, with a hole in the middle. So this is fairly simple. Now the other thing is that I need this to be 1mm thick. So if I come in and scale it down, I can just use this to scale it to 1mm. The problem with this is that if I've frozen the transformations on this or something, so let's just make it a bit wider, so make it say this wide, and then I come in and modify freeze transforms, as I've done with several other things, and now I want to make it 1mm wider, so I put this to 2 to make it another millimeter. You'll see that doesn't work. So I think I explained this in the introduction. So as we just scaled this in the first place, or I think I mentioned in the introduction why I'm doing this the way I'm doing. So we go to the channel box, and you'll see I've not got the input node for it, so I can't actually change its thickness this way. Now there is a simple, easy way to do this. So I'm going to select the face here, I'm going to go Control E to extrude, and I'm going to extrude it out by 1mm. Now I know that this is 1mm, so I can come in, select these faces, remove them, select this face, remove them, and then just select the edge and fill hole here. So mesh, fill hole, done. I've got something I know is exactly 1mm thick. However, it needs to be thicker than this, because if I try and use this at the moment as an inner bezel, it's just going to fall down inside the case, and there's a big hole in it, and it's and it's solid, so I'm not going to be able to see the screen anymore. So let's take this face and this face, and now it's not solid but it has no thickness, so let's double click on all those faces, go to extrude to a thickness of 2mm. There we go. Now I can shove this thing inside the case with W here, and if you wanted to make it exactly 1mm on the inside, you could extrude it to a 1.1 and create a 0.1 overlap here, but I just want to make sure that's overlapped, and that's going to be accurate enough for me. Now my screen will now abut this, so let's select our main board here, and so our screen's going to be pressing against this, which means if we're a little inaccurate, we now only have to sand this little lip down a little bit to get a perfect screen fit. It'll also make our case look thicker when our screen is fitted to it, which I happen to think is quite a nice thing. So just a design consideration there. What we do need to do, however, is select our main board, select our bezel, isolate them, let's go into a sensible view here, and make the main board about this. So main board, here we go, let's come in, let's make that bigger, and make sure that sits nice and securely against our inner bezel. Okay, like that. So that will be the defined area of the screen now. Let's hit Control 1, and as you can see, everything fits together nicely. The only thing that's going to be still an issue is these four chaps here. So let's come in and select them and combine them together. Now I'm going to select the main board and this combination, one down here, Control 1 again. I'm going to select the vertex of these and just make sure they're in the right place. So very simple operation. We come in and I'm going to zoom in a little bit because it wouldn't do to be inaccurate at this point, and there we go. Done. So our main board now fits the front of the case instead of the back of the case. Now we need to do a quick sanity check, a quick look around to make sure that our main board is not bisecting anything. So we've got our nice screen hole cut out the front there, and I've just noticed that these mini support pillars are now in the way of the screen, so it's probably the case on the other side. So I'm actually going to just select them and remove them. We didn't need so many, we've kind of over-engineered this, which is fine, but rather than trying to make them thinner or make them disappear, I am just going to get rid of them in their entirety. Now, one last thing to look at with this, because we've moved the location of all this stuff, if I hit case front, we have them all there, we reorganized them, but we did not reorganize these pillars. So let's break them apart for a start. So mesh, where are we? Separate. Okay, let's put them all into a group. So modify, edit, delete by type history. I'm going to get rid of the history on them. I'm going to move them out of this group because I do not want them in there, and I'm going to throw them in the front group, case front. Okay, so select the whole case front, make sure you're not having an issue. Now we're having an issue. Moving that case front was extremely slow, and also you'll notice that when I moved it, the Boolean operator is still in there, which is why it was slow. So now my hole is gone. So that's obviously not what I want to do. So I'm going to delete the history on this. Mesh, delete by type. In fact, the Boolean operator has gone in the case front group and the case itself is not even in there. So modify, edit, I don't know why I'm getting that wrong today, excuse me, delete by type, and history, there we go. Drag the case front into the case front group, and that should be working perfectly. Now I want to freeze the transforms on my case front group because it's exactly where I want it to be. So case front group, modify, freeze transformations, there we go. Done, and let's bring the case back, so Shift H. Now we know that's there. Let's move the case front group out, and we are good to go. Now we could indeed also, before we do that, make sure the main board group is zeroed in, so freeze its transformations. And I'm going to middle mouse drag the main board group into the case front, so I can just move the whole thing in one go. Now we also forgot to put the bezel in. Sorry, I seem to be having a senior moment today. Let's put the bezel in the case front group, and obviously I would give that a name as well, so it's not just poly object number 621. And now we've got a nice hole cut in the front of our case with the screen. We've transferred the main board from the back of the screen, back of the enclosure case mounting, to the front. That way when I have to attach wires from the main board down here, when we pull the case apart, I won't accidentally yank all the wires out. So we need to now also cut a button for the front, so I'm just going to control duplicate this button. I am going to find out where that went. It went somewhere in the group, so button top. I am going to select this. I am going to control select the button top, and I'm just going to go mesh Boolean difference. There we go, and our button top will have disappeared. I'm once again going to delete the history on this, so modify, edit, delete by type history, there we go. And if I hide the button, we should see that we've got that perfect hole cut in there. Okay, so if I pull just the case front out, not the whole case front group, there we go. So we can start to see our little device come together here. So what we need, the only thing left really, is the binding post holes, and they're just mounting holes. So it'll literally be a case of creating 3 cylinders and chopping the hole. Then we need to deal with this zip socket. This is the last thing left that might pose us any issues whatsoever, because if we look again at our picture, you'll see that it's actually got a little handle that goes up and down. Now this handle pivots to an upright position and to a downright position to unlock the zip socket, which means we'll also have to cut a hole along the side of the case here. But we'll tackle that in the next part. The next part should be the final part. We will tackle the zip socket, then we'll export this thing as an STL file and import it into a 3D printer slicer, and just make sure that it all works as we expect it to. So thank you very much for watching. I hope you got something out of this, and I'll see you in the next part. Hi, welcome back. So in this part we're going to deal with the zip socket on the front here. Now I'm going to bring up the picture, and you can see our zip socket actually has this kind of locking bar feature on it. Now I'm going to want to make a hole in the case for this, but what I'm also going to want to know is when this pops up, does this bigger head actually hit the side of the case? Because if it does, we'll have to make allowances for that. So let's go ahead and bring in a couple of pipes here to represent this. So I'm going to bring in a poly pipe, and actually it's a poly cylinder, not a poly pipe, my apologies. And E, J to lock the rotation, just rotate it around this way. Now we need a size for this, so we could, if we wanted to, go by I from our picture, but I actually measured the size. This is approximately 12 millimeters long, so I'm going to come into its input node and give it a height of 12 millimeters, and that should match up pretty well with the picture, and it does. Now as to its thickness, I think I measured its thickness at about 0.7 in diameter, in radius, sorry. So let's go to 0.7 here. Done. And yeah, that matches up perfectly with my measurements, which is always nice. Let's create another cylinder. So we want another cylinder here. Just going to move it down. I'm going to do the same thing. I am going to rotate it. J to lock the rotation. There we go. And chuck it on the end. Now my measurements for this were 7.5 millimeters, so let's give it a height of 7.5. That seems to be about right, and the diameter of this one's going to be important. The radius, sorry, so it was a radius, I believe, of 2.25. So let's come in 2.25 and see if that matches. That matches perfectly. Okay, let's make sure those are together. Now I'm going to actually combine these objects together, so let's select this one and this one and do a mesh combine. Combine, there we go. And now I'm going to move them up to where the zip socket would be. Let's focus in on this. So it should be around here. I'm using the reference here a bit. And now let us move this into the main board group, which is attached to the front of the case, so this must be out of position. It is. Okay, that should have snapped back. It could be the rest of the scuffings is out of position. Let's see. So where is the case front group gone to? There we are. So is the case front group out of position? It is. And then this. Okay, somehow our case front has got away from us. Not a huge issue. We just need to move it back into position. I'm actually going to hide the back of the case here. My apologies, I must have made a mistake there. All we need to do is make sure our case front is bisecting this, of course. So, did I make a mistake here? Let me see. No, it is just as simple as I've moved it out of position and frozen its transformations during probably a demonstration or some such. So just move that in until it bisects the front again. There we go, and reset its freeze its transformations. So modify freeze transforms. There we go. Sorry about that little mistake there. In fact, is that bisecting? Let me just move it forward a little bit more just to double check. There we go. Now it's bisecting. Alright, fair enough, my mistake. So modify freeze transforms. Okay. Now let's move our handle thingy here into position on the ZIF socket. So actually, is the ZIF socket clear enough? that we do not need to cut a hole in the side of the case, because that would be very, very nice. Let me just check we're lined up on the picture. We are lined up in the picture. Right, excuse me folks, I'm just going to do a quick measurement as to how far down this bar goes into the zip socket. Okay, this bar actually goes 6mm down into the zip socket, so we need a way to do that. And I'm going to use this, and I'm going to isolate this and just the zip socket, and isolate it in this view too. Here we go. So we need to push this bar 6mm down this way. Now I'm going to center the pivot on this. Actually, I've still got the zip socket selected, so that's why. So if we go, this being almost 1mm, 2mm, 3mm, 4mm, 5mm, 6mm, and then a little bit extra just to be on the safe side, and then we bring everything back, you can see that our bar here is most definitely intersecting the side of our case. So if we'd have printed as such, we wouldn't be able to fit the bar in. The good news is, I think if we select this object and we line its pivot point up with the back, so insert and just align its pivot to, let's see, best way to do this, to the end here. So I'm going to align it to this vertex in the middle. There we go, hit insert again. This way I can actually do a sort of impromptu animation here, just to make sure that the top of the head is never going to hit the case. That way we can cut a much smaller hole out. Alright, so let's reset the rotation on this, and now I need to create a object to cut this. But first, let's cut the zip socket itself. So edit, duplicate special, there we go. I'm going to select that, I'm going to select this, I'm going to go to mesh, boolean difference, and whoops, I got the selection order wrong. So again, something to watch out for, mesh, boolean difference. And that should actually cut my hole now. Now I'm going to hide this zip socket representation, and I need something this thickness to cut the bar. So I'm going to do this one by eye. I'm going to bring in a box. I am going to line it up, so this is not the best view for it. I'm going to line it up. I'm going to make it this thick, just ever so slightly thicker actually. I don't want to be chopping huge holes in here. But I do want to give myself enough clearance to make sure I am good. So, okay, and we want to line that up where it would be on the zip socket. Again, a little bit extra room, just a little bit. There we go. So just slightly larger. Now I need to make this wide enough so I can use it to chop through the case. Move this out here. Use this view. And we want to get it so it's just a little bit over that, and now I can use this to cut the hole where the bar would go. So selection order being important again, mesh, boolean difference. Okay, and now I've got a nice little hole cut in the front of my case. So if I were to rotate this, you can see we've got room to do that. Now let's bring back the case front, our hidden object, so that will be within the main board and it will be ZIF1. So you can see I have now room for the ZIF socket. So if I come in and hide everything that's poking out through the holes in the front of the case, just so we can see, we've got the holes in the front of our case nicely cut. So other than the binding posts, we're just about finished here. So let's go ahead and do those. And my binding posts, the things we looked at the front of the tutorial, the things I'm going to use to connect to the inside gubbins of this, have a mounting hole size requirement of 3.7mm in the radius. So let's go ahead and make this 3.7. Okay, and that should be good enough. Now all we need to make sure is they're wide enough to use as Boolean objects, but they should be more than wide enough. Now I also need to create 2 more of these because I have 3 posts to go through the front of the case. Now in this case this is going to be a little more tricky because, let's see, so let's E to rotate. Oh, actually no, I hit extrude, so make sure I undo that extrusion. E to rotate, J, just get them down to 90 degrees, there we go. And I need a few more of these, but I need them a certain distance apart. I don't just want to go, you know, D, W, one there and kind of one there and just call it close enough, because it's not. Now I looked up, there is an industry standard spacing for these kind of connectors, and that's approximately 19 millimeters. It varies slightly from depending on who you ask, but I'm going to go with 19 millimeters. So I need to duplicate this and then move it this way by 19 millimeters. So let's go 19, and these should be 19 millimeters apart. Let's get a bit of confirmation on that, shall we, with the measure tool. So I'm going to create measure tool, distance tool. I'm going to click here and here, and they are in fact 19 millimeters apart. So this then becomes fairly simple. I need another one that's 19 millimeters apart. So I'm going to Control D, I'm going to move it out, and you'll see what's happened here though is because this is already 19, easy way, modify, freeze transforms, and then just make it 19 again. There we go. So these are all exactly where binding posts should be. Let's bring them down to the front of the case. Now I'm going to line this one up with the exact center of the case here, so we are having 3 holes that are very central. I'm going to move them up as far as I can here because I want them away from the bottom of the case. Let's make sure these are bisecting. Let's just make them a bit longer. Okay, because I froze the transformations on one and not on the other 2, you'll see some strange behavior, but that's fine. We'll just freeze the transforms on them all. Done. And now I can make them a bit wider and chuck them in here. So select them one at a time. You can probably do all 3 at once. Let's just give it a go. Normally I like to do my booleans one at a time, depends and difference. And that's cut the holes for our binding posts. So that pretty much completes our project here. What I'm going to do is I'm going to go and print this out. I'm going to double check everything, make sure everything is intersecting. This battery holder, for instance, might be a little too fat, so I'm going to make it a little smaller. There we go. And make sure everything's bisecting. I'm going to do some final measurements with the measure tool just to make sure everything is in its proper place. Make sure we don't have like a screen hitting any sports anymore. We do not. And that should be about golden. So I will come back when I've printed this thing. I've got some images for you guys to have a look at. Let's bring the bottom top back and the zip socket. And we're going to have some proof here that we haven't wasted our time with all of these measurements, that we have indeed managed to create something that's pretty accurate within Maya itself. So let's bring the case back, case back. So there should be a hidden item in there. There is Shift H. Let's select the whole case front group. And okay, so we've got some history left on the case front group. That's not an issue. I just need to delete that. You can see that that took a long time to move, which is not what we want at this point in the process, but it shouldn't really matter. We should just be able to case front here. This is part of the case front now. Edit, delete by type history, and I should be able to move these 2 things, which are most certainly part of the case front, into the case front group. This thing should now not be important, so it can just be deleted, and now I can move the case front out. Okay, so, and we got the frozen transforms on it, so we can move it back. Let me just check the main board, also has the same thing. And yeah, if I want to move that back in relation to the case front, I can just do this. Alright folks, so we are pretty much there. As I said, I'm going to print this out now. and then come back with you with hopefully a fully functional prototype of this case and the accuracy we needed in Maya. Thank you very much for watching, and I'll see you with the last final sort of cleanup part in a while. Thank you. Hi, welcome back. So in between the parts I went ahead and did a test print, which I can show you here in Lightroom. Now excuse the sanding on this, but as a proof of concept it worked particularly well. Our fit and finish are great, the screen fits, although I would make this a little smaller because we can see the corners of the LCD here. But other than this, our holes were cut correctly, our mounting systems all worked, and the case went together perfectly. Now, we've talked about using Maya for this kind of thing and what it's good at. Let's have a look at what it's bad at, because a test print like this, I can see here around the corners we had too much support in edge geometry, which is why we've got this sort of ear effect here. And we need to change this. Also, there's too much plastic up here, so I want to round these corners off. Now, this is where Maya starts to fall down a little bit. Because I have smoothed the outside of this case in order to cut the holes in it, coming in now to change this to sort of round the corner more up here, maybe make it a little thinner at the bottom because we've got quite a bit of room here that we don't need. Maya's very bad at this. If I could come in and I edit the vertex here, you'll see there's a whole ton of them, and it's not quite as simple as grabbing some vertex and moving them over, because I'll get this. So we actually need to go back to the unsmoothed case. Now, I've already done a redesign of this in between the parts. I'm going to go over it again with you. And all Maya does really let us down on this for this kind of work. It took me about 15 minutes to come in and rechange an unsmoothed version, so really it's not that bad unless you're making hundreds of changes. So I'm going to go and bring in the unsmoothed versions of the case, which if I Control 1, you should remember from an earlier part. Now I believe I also added some instructions within part 7, I think, telling you to keep a copy of this before you smooth, so keep a duplicate. Now you're going to want to do this every time you smooth something in Maya to cut holes in it. You want a copy of it. Now this is for this reason, because if I come in here and I want to edit this now, it becomes much easier than working on our high geometry version. So first things first, let's move these case halves together. So I'm going to look at this one, I'm going to look at where it is in relation to the back, and it should have come in exactly the same place. It did. So let's select these two again and isolate the view, which means all we need to do in order to get this one in the right place is just marry the case halves up. I'm going to use the side view for this, and this is a bit of a pain, but it is really one of the limitations of using Maya as opposed to a more purpose-built CAD program. Now, because I want to work on both halves and get them exactly the same, I'm going to actually combine them together temporarily. So mesh combine, there we go. Now, oops, let me uncombine this. Yeah, let me just make sure it is in the right place. Done. Mesh combine. There we go. Now what I can do is edit these edges. Now one of the reasons we were getting this little ear effect here is too many supporting edges. So let's take some out, and I'm just in edge mode, double clicking on some of these edges to remove. Now of course the front and back are just temporarily joined together, so I will have to select all of the edges, front and back. This part of the process in Maya can be a bit of a pain, but it really doesn't take that long. So I'm holding shift and right mouse button to delete the edge, because as I've said before, if we just delete the edges on their own, they will end up not looking right. They'll end up leaving vertex behind, which we don't want. So let's think about this a second. Now I want to curve this in a lot more, because in the final design this is too wide up here. It'll look a lot sexier if we curve it in a bit. Now none of this is necessary, of course. This is just now purely for design aesthetics. Our design actually functions and works, so if you wanted to leave it at that point, you of course could. I'm including this part in here just as a demonstration of what happens if you do your prototype print, your test print, and you're not happy with the end result. So we've taken those out. Now we'll need to curve this in, which means we'll need another edge loop around here. So we can just go into the modeling toolkit, multi-cut, and start adding edge loops. However, we need them at the same point all along. Now there's several ways of doing this. A really simple one is just to take a polyplane as point of reference, scale it up. I think, where do we put that? Scale it up. There we go. Select our case halves. There we go. I'm going to flip back to object mode. Done. And now I can raise or lower this depending on where I want my edge loops. So for me, I want another loop around here. Now I can come in and use the multi-cut tool on the right object, of course, and I've got a point of reference. Now is this just for adding a curve? I'm not going to worry about being accurate to within the micron, accurate to within the tenth of a millimeter or so will be fine. And there we go. Ooh, that last one was a bit sloppy. There, done. Now I can get rid of the plane, and I've cut in my edge loop. Now all I need to do is select my vertex over here. Now we're back into a more traditional Maya modeling sphere, and hit R on the keyboard to scale and move that in a little bit. Now it might help us to see this smooth right now, and there we go. That top of the case is much nicer looking. So let's go to object mode and make sure there's nothing wrong with this. I'm going to do shading. I'm going to turn off wireframe unshaded so I can get a better look at it, but that looks a little bit better to me, a little bit sleeker than what we had before. Also, I mentioned I might want to end up scaling in the bottom, so vertex R and just scale it in a little bit. Let's go to 3, and that makes us a little bit smaller around the bottom. Now your problem here is going to be, let's go to control 1, mesh separate. There we go. I'm going to hide this part and hide this part. Now your problem is, of course, and these should be separated again, while we've got them in the location that we need them in. Let's do a modify freeze transformations. Done. And same again, modify freeze transformations. Done. That actually freeze. Yeah. So just to iterate the point again, if I move this around, I can easily move it back. So we are going to have to repeat our smoothing operation, but as we've done it before, it really shouldn't take us that long. So let's just remove these faces. Object mode. Now you'll want to keep a copy of this in case you need to change it again, in case you're not happy with the design. So I'm going to go ahead and hide that and mesh smooth. Actually, let's do 3 on the keyboard to get a smooth preview, and then convert it to the smooth preview. So convert smooth mesh preview to polygons, and we are done there. And same for this one. So keep a copy of it, hide the copy, and just remove these 2 faces, 1 and 2. So this is just really one of the limitations of using Maya. It, in most cases, doesn't turn out to be too big of a deal, because say I did redesign this thing in between these parts, and it took me 10-15 minutes. So it's not the end of the world. We're looking for convert smooth mesh preview to polygons. Then of course we'll need to fill them in and recut the booleans. So I'm looking for edge mode here, and I want that edge, mesh fill hole, of course. There we go. And I want this edge, G to repeat the last command. Let's just do this one. So we're going to want edge mode, and whoops, let me get a decent viewport. G, and flip it round. There we go. Whoops, might have been handy if I'd have isolated this in the viewport first, but not to worry. There we go. Alright, so most of our external bits are in place. We need to recut the holes. Again, this shouldn't be an issue because we'll either have copies of our Boolean objects or we can just make them again. In the case of something like this surround, let's take a duplicate and let's say we wanted to recut the screen here and we hadn't saved our Boolean object, we could just remake our box from the screen size, or if you want you can actually reuse something like this. So if I come in here and let's say I select my face here, and just extrude inwards, so Control E, give it a thickness, that'll do, and cut out the outside. So I'm going to remove these faces. I am going to remove these faces, then finally these faces. Then I just need to come in here, bridge across the corner parts. So could we bridge this all in one go? Probably not. Let's do it this way. Now in this particular instance it would have been quicker just to go into the front view, resize another box up, because you know essentially it's a box with a bevel corner. I'm going to do it this way just to show you can. Let's bridge this. Okay, that's not liking that bridging all at once, so let's just bridge it individually. Pain in the backside. Like I say, personally I would probably end up just resizing the box. So we should be able to bridge this, and indeed we can. Technically we should have been able to bridge this all in one go. I think Maya might have had a bit of a conniption, however, had we tried it. Alright, so that gives us this back. Now if you're thinking it's got a hole in it, it really doesn't matter. Let's make it a bit wider and center its pivot. Okay, it really doesn't matter because when we use it to cut the hole, now one thing I did mention was that I wanted to make this thing a little smaller. So easy way to do it would be just to scale it down just ever so slightly, like so. Okay, I'm going to keep a duplicate of this because I'm going to need it again in a minute. Whoops, I think I duplicated both objects there. W, move the duplicate out. Now you'll see what happens when we use this to cut a hole, you know, because we're going to be left with some remnants. So let's select this, mesh, booleans, difference. Okay, and you'll see we've been left with this remnant here in the middle. Now I'm not sure why. Okay, let me just try that again. Something very strange happened. Let me delete the history of this object. So modify, where are we? Edit, delete by type, history. There we go. And this one too. Done. And let's do that again. Mesh, boolean, difference. Okay, you'll see that's done some very strange things with our corner pieces that it really shouldn't have done. Let's take a look at this object. See, in this case it definitely would have been simpler to just cut the box again. Or even easier really if I'd have actually kept a copy of the original object we used for the first boolean. But this should do the trick. So I'm just going to cut edge loops in here to make proper Maya geometry. Okay, I'm just going to pause the video while I do this. Okay, so that's all done. Took 30 seconds or so. In this case, it would have been easier just to recreate the box window using the reference image. But again, if we'd have had a more complicated shape. There is one other thing that I'd quite like to do, and that is I would like to cut like actually easier to show you. Let me just select the edge, and what I would like to happen is this to go like this and this to go like this, and I want to cut a sort of deeper groove in it so it makes the screen bezel look a bit nicer. Now I'm just doing this by eye. You might want to take some more time over it, but this should be fine. So when we push this through now, make sure it's gone through the back. Done. I'm pretty confident that this will cut just fine. So mesh, where are we? Booleans and difference. Yeah, that did. And you'll see it's left like a groove in here, which I think will look more attractive just slightly as a design aesthetic. Now I've also got this in the way, which is absolutely neither use nor ornament to anyone, but it's very simple just to select the faces here and get rid of it. There we go. So if you need to rebuild a boolean, you can. You can also come in and adjust the size of this by selecting the verts. So if we were to select the verts around here and then scale them or move them, you can adjust the size of this bezel lip around the screen. Okay, now it's just a simple case of using our Boolean objects here to cut the rest of the holes in the case. So if you find yourself in a situation within Maya where you've smoothed an object like this, but you need to come back and rebuild it, you'll need to keep a copy of the unsmoothed one, as I think I mentioned in part 7. That is a Maya limitation. Something like SolidWorks would allow you to change it on the fly much more easily. However, there's minuses in things like SolidWorks too. You're always going to run into some drawbacks when you do this kind of thing. Now, for me, I am done on this. I will cut the holes between the parts, do a print. I will then come back and show you how to export this to an STL file. I will go over some of the basic settings that I use within the STL file for this, although it's outside the purview of this tutorial to go into everybody's 3D printer settings. I just wanted you to see what it looks like in the slicer application. And then I'll come back with a fully printed, sanded and painted model. I'll probably spray this one and clear coat it. So thank you very much for watching. I hope this has been somewhat informative, and if there's any takeaways from it, it's really just to keep any objects that you decide to use for beveling, for Boolean purposes. Because if I'd kept my original object, it would have made cutting the screen slightly easier, of course. And again, most of these I've kept. So now we'll need to, just one more thing before we go. Do not forget you also need to put 4 more holes in the back of the case. The supports and everything else remain constant. So really this process is just unsmoothed object, come in, make sure everything fits, change it, and then re-drill or re-boolean any holes you might need to do, unless you've done sort of a major design change. As you can see, everything here in terms of supports fits just fine. Okay, so I'll go away and, as I said, print, and I'll come back and we'll finish this bad boy up. So thank you very much for watching. I'll see you in the next part. Hi, welcome back. So in between these parts, I've taken the liberty of printing out our objects here to make sure the fit and finish work. I can tell you now that everything worked exactly as we planned it to. So really no problems here. Just a couple of very quick points I want to cover before I sign off on this tutorial, and that would be how to export this to an STL file for your slicer. So we're going to go up to our case, and if we just hit File, Export right now, the option for STL probably won't be available. First thing you need to do is go into Windows, Settings, Preferences, Plugin Manager, and you need to scroll down until you find the plugin. Now, by default, it's not armed within Maya. Maya will actually do this. You know, it's built into Maya. It's not a third-party plugin. You just have to turn it on, basically. So if we look STL Translator, we need that ticked. And then we should be able to export to STL. So to export, you don't have to group the objects together or anything, although it's nicer if you do. So I've got a case front group here, which would be everything that prints in one go. I'm going to go ahead and make a duplicate of this group, and then I'm going to do a mesh combine, as we've done before, and that creates one poly object. Then I'm going to go ahead and hit File, Export. Export selection rather than export the whole scene, and you'll see here I've got STL export as a file type, so I'll go ahead and export that as an STL, and then we'll quickly open this in a slicer. Now I'm going to use this one. It really makes little difference. That would be down to your 3D printing preferences. I just wanted to show you that it opens up fine in the slicer. There's no issues with it. And if you go into the preview of Cura here and I go down the layers, you can see where we have intersected the model rather than physically joining it together. The slicer just sees that all as one thing. So we should have no issues printing this. Now on that score, I did, as I mentioned, go ahead and print it. So I'm just going to flick open the images of that one and we can take a look at it. So here you can see we've printed it. It fits our components perfectly. If we look at the side, you can see the case fits together very well. As we expected, Maya is most certainly more than accurate enough for this type of work. So, you know, using Maya, within a couple of hours, we've created a prototype here. The fit and finish are great. I printed this on very poor quality print settings, just 0.3mm to give it the strength it needed to be this sort of case, and with a little bit of sanding it finished off absolutely fine. As you can see, everything fits perfectly together. So that's going to wrap this one up. If there's interest in this kind of stuff, you can feel free to let us know on our forum. You can contact me personally, David at SimplyMaya, if you have any questions. We may make some follow-ups to this if the interest is there. So thank you so much for watching. I really hope you enjoyed this series, and I'll see you again for the next tutorial. Cheers.